We're going to briefly cover what is drip irrigation anyways. Then we'll go over the components of drip irrigation. We'll talk about drip irrigation basics of design. We'll talk about an approach to retrofitting. So if you have an existing spray irrigation system, like there's an area of lawn that's no longer lawn and you're going to convert it to drip irrigation, there's some techniques and some parts that can make that easier with still keeping all the pipes you have in the ground. Then we'll go into more detailed layout and design. We'll cover some basics about drip maintenance. It's not complicated, but it does need to be done. It's just a few things you need to be aware of that make all the difference long term. And then we'll finish up with as much depth as we can get into with scheduling, how to know how long and how often to run your drip irrigation system. Somewhere in there, about halfway through, we will take a 5-minute break or so just for a breather, and there will be time for question and answers as we go. And so how to communicate, how to ask questions today. So we have 99 people currently in the workshop. It's a bunch of people. Awesome. Thank you for joining us, everybody. And that's too many people to be able to really successfully call on individual people who like raise their hands and have them talk with the audio up and down and all of that sort of stuff. So what works best for these workshops is as we go along, if you have a question, type that into the question and answer function in your Zoom interface. You'll see, for those of you who are new to Zoom, a button in your little Zoom interface panel that says Q&A and has a couple of little chat or little text bubbles. It's the one with 2 text bubbles that says Q&A. Click on that. That'll launch the Q&A interface. Type in your questions as we go. The questions that I'll be able to answer as we go along are going to be questions really pertaining towards what we're talking about. If you have more specific, like here's my situation questions that might not be relevant to the majority of everyone else there, I will answer as many of those as I can. But in general, I'll often need to wait till the end of the workshop to answer those. And then I'm happy to stay a while after 12 to answer as many of those as possible. And so I keep an eye on that Q&A interface as things go. And then I will just stop once questions have come in at a good stopping point in between topics and answer everything that I can. For the chat, that's more use the chat button and that chat function more for just general comments. It's a lot harder to monitor just for the workflow on my side, the actual answering questions if questions go into the chat. So please use the Q&A for questions. Sometimes I miss them if they come in on the chat. And so with that, I'm going to take a sip of water and we will jump into it. So starting with what is drip irrigation? And so to some people, this is going to be obvious right now, but the short answer is, as opposed to an irrigation system that sprays water through the air, drip puts water out slowly from individual emitters, dripped directly onto the soil surface. And there's a lot of misinformation on the internet in terms of the purpose or the use of drip irrigation. Kind of because of the history of it and the multiple uses of drip irrigation. So if you just look at some of these internet examples, for top one is a system of crop irrigation involving controlled delivery of water directly to individual plants through a network of tubes or pipes. So obviously for our home landscapes, unless it's our veggie beds, it's not crop irrigation. You'll also read some stuff on the internet about how, as opposed to spray systems, drip is run briefly, on a daily basis to maintain constant soil moisture. That's kind of a remnant of when drip was primarily used to grow vegetables. How we use drip irrigation is not necessarily different in terms of how we manage our soil moisture, but it's used because it is an efficient, flexible way of applying water directly to the soil surface where it doesn't fly through the air, get blown around, or potentially have evaporative loss. It's applied directly on the soil surface through drippers. Key things about drip irrigation is no matter what kind of parts you're using, and it can get very overwhelming to go to the hardware store and stand there in the aisle with all of the drip parts and wonder what you should do. A big part of this class is going to basically simplify that. And essentially at the end of the day, for most of us, a lot of this stuff is junk. Doesn't hold up over time, doesn't work well to water your plants beyond the first couple of years as those plants grow and their roots want to find water farther out. So if you are successful with all of these little kind of custom parts where you have a system that does 10 different things at once, I'm not telling you to not keep doing that, but what I'm going to present today is what's going to work well for most of us, what's going to be the easiest to maintain over time, and what is going to keep our plants healthiest in the long run, especially if you're working with water-wise or California native plants. But things that are common to pretty much all drip irrigation. They run at low pressure. Pressure regulation is essential. They're engineered to run at low pressure. If you just connect it to your water system without pressure regulation, it's not going to work well, and it will break apart over time. Water is applied directly to the root zone and doesn't really fly through the air like sprinklers. And there's a place for sprinklers, but it's one of the main differences with drip. It applies water individually to single points or multiple points along a piece of pipe or tubing, so it's not a spray. And the different types include point source. Those are those little buttons or doodads that you either snap directly into a half-inch pipe or have that small spaghetti tube. Low volume or micro irrigation. And so some of those are also called micro sprays. We'll talk briefly about that. And why choose drip irrigation? So why is this appealing to people? Why do we hear so much about it these days? High irrigation efficiency is one of the main reasons. And that's also a term, we're not going to get super into it today, but you might hear the term distribution uniformity. And that means over an area of irrigated garden, property, landscape, whatever it is, when that irrigation system turns on, how even is the distribution of that water when it actually soaks into the soil? And so because unlike spray systems that are flying through the air, there's wind, there's individual points that shoot very far, it's very hard to engineer something that lands perfectly evenly. And so then sometimes additional time is needed to compensate for the areas that get less water, and you end up watering deeper than you need to with the areas that get more. Drip, well installed, is almost a perfectly even system of watering, high distribution uniformity. And if you have a mixed garden that has trees and shrubs and all sorts of other things, you don't need to worry about something closer to the sprinklers that's taller being hit by the sprinklers and having kind of an area behind that plant that remains dry because the drip goes underneath everything. Because that water is not flying through the air, it doesn't evaporate. That evaporative water loss is minimized to essentially not there, which is big. I mean, if you have overhead sprinklers, you should be watering in the evening anyways. One of the nice things about drip irrigation is that you have the flexibility, and this is especially true on commercial properties where there's a lot of things to be watering. You have the flexibility of watering at more different times during the day. So a lot of control over where exactly that water ends up. If for whatever reason you have to apply more water just in a local situation, you can do that. If you have a landscape area where one section, for example, you have fruit trees and then immediately next to it, you have low water plants, and with a spray system, there'd be no way to give each section of the garden just what they want. With drip irrigation, because the tubing is flexible, you can set up one area to be higher water, one area to be lower water next to each other. You're going to want them on different valves so that they can water at a different schedule, but spatially, it's very flexible. In some cases, because you're only applying water where you want it to, you can have reduced weed pressure as well. And then finally, drip is often a very good choice on slopes because it does put out water relatively slowly compared to traditional spray systems. And because you do have so much flexibility in the distribution of it, it can lead to reduced erosion compared to like big impact sprinklers or sprinklers that put out a lot of water on slopes. So that's another kind of advantage of drip. However, drip isn't always perfect. And so we'll mention some of these aspects later. But the first thing I want to mention, I'm going to actually go back to look at this picture right here. You can see how this is a relatively large area of a garden. This is probably a 1,500 square foot section of a garden, at least if we include the landscape that's just out of the picture. And that's a lot of tubing to lay out and maintain. It's not cheap to install. And then there's a responsibility of kind of listening, making sure you don't have breaks, all that sort of stuff over time. If there is a way to set an area this big that's all similar water demands, depending on the heights of the plants, if there is a way to set that up for very high efficiency spray system, different design, different spray nozzles than a traditional spray system with a lot of misting, but a high efficiency spray system like you might hear rotating sprinkler nozzles, I might do an area that large with that approach, depending on the plant height. So if the plants are too tall and those sprays would be blocked, I'd go with drip. So that's one advantage, especially coming from a sprinkler system. Sometimes it's easier to convert to that high efficiency spray. Sometimes drip is better, but that's one consideration. If you are interested in learning more about the high efficiency spray approach and really like how you would look at one garden area and assess what approach you want to go with and how to do that, I highly recommend you check out on our YouTube channel a class we have that's Retrofitting Turf Irrigation Systems for water-wise and California native gardens, where we talk more about the different approaches and the merits of each one. If you are going to go with drip, because that's going to be best for your layout, and that's normally what I think, what's going to be best for this garden area, what's going to be the most efficient system, that's a balance of water efficiency and installation and maintenance efficiency. So the other thing is that you need to know about design and maintenance needs to be installed correctly. We see so many drip irrigation systems in the work that we do here installed incorrectly. And so this high efficiency of a drip system only comes with correct design and installation. If it's not installed well, you lose all of that. And we see a lot of drip irrigation systems installed that are not really set up well for the long-term health of the plants. And irrigation exists to keep your plants healthy and do so efficiently. So a drip irrigation system that doesn't keep the plants healthy long-term, that's not putting the water where the plants want it, it doesn't matter theoretically how efficiently it is. It's not doing the job of an irrigation system. And so we're going to talk about that. But there is some knowledge that comes with it that's a little bit different than sprinklers. And maintenance is not difficult, but it's different. The filters on drip systems need to be flushed and cleaned, generally only about twice a year at the most if you're on like a municipal water system. But if that never happens, and we do see that a lot, and you're 5 years out and things are starting to clog, sometimes people don't notice till their plants start to die. So it just takes less than a minute usually, but it needs to happen a couple times a year as a general recommendation if you have relatively clean water. And if there are breaks, cuts, issues for whatever reason, and you're not paying attention to what's going on, those can go unnoticed for long periods of time. Sometimes it's not until plants start to die or look off, because if there's a break in a drip irrigation system, everything's under mulch or under plants, you may or may not notice, where as opposed to a spray system, if there's a break, there's a huge geyser, you're more likely to notice it, or you see an area flooded the next morning, and it's a pretty quick indicator to fix it as long as you're paying attention. So it needs to be properly installed. What is proper installation? Well, that depends on your irrigation design, but in general, proper installation, how I am going to define it for most landscapes, is that the root zone of the plant, so not just right at the base of the plant, but the root zone of your plants is being watered and evenly. So that's a common thing where drip irrigation systems are often, they kind of go wrong, is that outside of maybe cacti and some succulents that are really adapted to very constrained root zones. And so if you have a true desert garden, you can sometimes get away long-term with just a couple of individual drippers kind of poked into the line at the base of the plants. The vast majority of our water-wise plants want to grow big root systems far and wide once they get established, or as they're getting established, and they want to pull their water from kind of this wide area around them. And a lot of them are actually sensitive right at the base of the plants to being overwatered and can have problems with rotting out if that's where too much water is accumulating. And so we're going to talk a lot about what are called drip grids, which are some kind of examples, as you can see here, especially in the lower, middle, and right, where as those plants grow in, they're going to be able to access water kind of all around them. And that is going to keep your plants happier and healthier long-term. It takes a little bit more work to plan But after year 2, 3, going to year 4, 5, you want your plants to be long lived. That's what's going to keep them well supported. So a couple of questions that came in before we start talking about the system components. So from Milton, what's more efficient, buried drip irrigation or on top? On top, most drip products are with the inline emitters are meant for either application. Some of them aren't meant to be buried, but a lot of them are, and you can find that with your product specs. Either way, as long as the drip lines that are on top of the surface are covered in a layer of mulch, whether that's wood chips, gravel, decomposed granite, something covering it up, the efficiency into the soil is going to be relatively similar. Water is going directly onto or into the soil, and the evaporation is going to be minimal to none. So what I focused on more is what's going to be efficient after that to maintain over time as you're doing landscape maintenance, changing plants, and what's efficient to install. So unless there's real specific issue where you would need to bury it, like sometimes high foot traffic areas in public spaces, if the mulch layer isn't going to be maintained, that could be an issue. But I pretty much always do drip on top of the surface of the soil and cover it in mulch. It's a lot of work to bury it. And then once it is buried, it's much more prone to being accidentally cut with a shovel. If there's gophers in your area, they're more likely to go through it, those lines. And then it's harder to find and then harder to fix those issues if they should get cut. So I pretty much always, unless there's a real compelling reason not to, put the drip on top of the surface. The only exception is if drip is being used to irrigate a lawn, which is still kind of rare, but in commercial landscapes becoming a little bit more common. That needs to be buried underneath the turf that goes down. Okay, so from Ramon, being that drip irrigation is the most effective way to water the landscape, why is there not available rebates from water agencies to convert overhead irrigation systems to drip? In a few areas there are. In more other areas, there have been pilot programs. But one of the things that is found is that drip irrigation to be efficient requires two things, maybe three things, you can say. The parts are part of it, but the proper design and proper installation is part of it as well. And so just giving people a bunch of like a box full of drip parts doesn't always lead to efficient installation and actual operation of the system, or even if there was a rebate directly for that. But water agencies are trying that in pilot programs, they're studying it, and they are discussing it. But it's a little bit less of a direct link than like tearing out lawn and putting in a water-wise garden, which can still get overwatered. So it's a very complicated situation, but people are thinking about it and experimenting with that. And then from Rodolfo, the types of dripper buttons that are most efficient for what plants. We're going to talk about that sort of stuff later on. We will be getting to that. Okay, so let's talk about drip irrigation system components. So some of the stuff we're going to talk about in this section, we're kind of going to spiral around a few times. So there's certain parts that we'll look at or things that we'll look at, and then maybe we'll mention them again during the design section. But that is on purpose because this is a lot of information to absorb. And so we find that kind of works well, is to lay out the parts, explain them, and then we'll talk about them more as we get into design. And I just saw one more question that came in. For those of you who have just joined us, please make sure to put the questions in the Q&A. It's hard for me to catch them in the chat, but I just saw one, which is about attaching to an existing underground sprinkler system. You would have to, we'll talk about that later, but you can potentially do that as long as you're ready to abandon the sprinklers. You can't run sprinklers and drip at the same time because they put water out at a completely different rate. And then for the person or the people who are asking about the copy of the slides, you will be able to download those slides as a PDF file at cbwcd.org/presentations, which I just put into the chat. Okay, so drip irrigation system components. If You have an automatic system where it's connected to an irrigation controller. It starts at the valve. Now, you can set up a lot of this architecture in a way where then you can kind of adapt it to a hose if you need to. I'll show some pictures about that later. But ideally, in most situations, it's connected to a sprinkler valve. And this is a pretty typical cross section of a sprinkler valve here of the valve operating part. In California and the West, a lot of our valves also have an anti-backflow feature. And so the threads that screw in come from the bottom, but the operation of the valve part works the same. And these things are confusing and mysterious to people. I will briefly explain it. If you don't get all of the details, that's just fine. But essentially, on the supply side of the valve, there's always that pressurized water from your water main system. And the valve itself prevents the water from going through. The reason why it's wired in is because when it is activated through the electrical signal, there's an electromagnet that allows, basically, long story short, the diaphragm part, the part that's blocking the water, to move up, and then the water is allowed to proceed through. There is also what's called a flush valve or a manual bleed valve. So your solenoid, the electrical part, is the big thing on your valve with the wires going into it. The flush valve or manual bleed valve is this tiny, small one. And that can be used to manually operate the system if necessary. Those pieces related to that can wear out. So it's kind of like, if for some reason the system's not working, you can do that. Occasionally, if for some reason the valve isn't closing all the way and there's just a tiny little bit of debris in it, you can also try to open that up to allow things to flush through, although that doesn't always work. So those are the two main ways of making the valve work. The middle size knob, usually that's directly on top, is the flow control. And in general, you don't need to mess with that. But if for some reason the flow seems restricted, it can open up more. Or occasionally you'll get into a situation where for some reason the valve isn't shutting down properly. And sometimes that's because the flow control is open too much, and you might need to tighten it down some. If for some reason there's a leak that you can't stop, you can tighten the flow control all the way down temporarily. But if the flow control is all the way opened, your valve also might not want to be able to shut off. So that's the basics. So flow control, don't mess with it unless you need to. And really the way these things are designed is for them to be activated by the electrical signal going to the solenoid and making the valve open. And so this is what a typical, in California, at least, an irrigation valve is going to look like. This is an anti-siphon valve. So this part on the right is the assembly that we were just looking at. And the water comes in through this side. But on the side where it leaves, there's also this anti-siphon feature. And these are the valves that are typical in residents in California, where they are sticking up out of the ground. The reason why in some other areas of the country you don't have the valve sticking up out of the ground, or on commercial sites you see them down in the box, is because those, if they're set up like that, that there is a large backflow preventer, usually where the water enters the property, which allows for that to happen. In our local landscapes, we don't have individual whole system backflow preventers where the water enters our property. And so we have the anti-siphon valve, which prevents water from backflowing from our irrigation system back into our pipes, where anything that's potentially little particles or chemicals that might be, especially with drip irrigation, connected to that water source on the surface, or that might be in our pipes, when there's kind of a suction change when valves turn off all of a sudden, and things could potentially, without backflow prevention, get back into the plumbing. And we don't want that. Even if we're not using chemicals in our landscape, it's just, we don't necessarily want whatever's in the irrigation pipes or in the soil getting back into our plumbing. And so the anti-siphon feature, which is this part, basically prevents that from happening through an air gap, essentially. And so occasionally, if you see water coming out of this, that's that anti-siphon feature in action. It shouldn't happen constantly, but it would just, if a little water squirts out when it turns off, that's what it's doing. It's preventing that water from potentially going back into your plumbing. Now, for these to work properly, though, the height of the valve needs to be approximately a foot above the highest thing that's putting water out connected to that valve. So whether that's a dripper or a sprinkler, and that's why they are above the ground in our yards. So if you are irrigating a tall slope, the valve either needs to be located at the top of the slope to work properly, or there are other check valves or other things that can be added so the water doesn't come down from the slope and overwhelm the valve. Your valves are usually going to be in the front or on the side of your house. Typical valve in a Southern California landscape on an urban property is going to be 3/4 of an inch. And that's basically matching the pipe size, 3/4 of an inch pipe. On a larger property, you might have 1-inch valves, and with a larger pipe, you can water a larger area. But 3/4 is really, really typical. And the anti-siphon, again, prevents that backflow. If you are working with drip irrigation, you absolutely, not optional, need a filter and a pressure regulator. And this is one of the places where we see people go wrong quite a bit. So at the Waterwise Community Center, for our local service area, we do offer a program where we will send a team out to assess someone's irrigation system, make a list of any kind of efficiency issues or breaks that we find for them, kind of a fix-it list, and recommend how they should have their irrigation system set up and their schedule to water efficiently. It is very common for us to see drip irrigation systems that have torn themselves apart with water pressure or are not functioning correctly because the drip parts were installed, but after the valve, there was no pressure filter, or there's no filter or pressure regulator. These are not optional. Drip components are not engineered to work at the standard pressure that's going to be coming through your water lines. That pressure needs to be reduced. And even with city water that's relatively clean, there's always small amounts of grit in the line, whether it's from the pipes that have been worked on over the years or whatever reasons. Tiny amounts, but over time, because the openings and drip emitters are so small, that could lead to clogs and issues. And so the water needs to go through the filter, which this filter can be removed and flushed. Generally, like I said, only needs to be about twice a year. And then through a pressure regulator. Pressure is, the unit of it is PSI, pounds per square inch. And drip systems are really meant, vast majority of drip systems, to be between 25 and 40 PSI. For standard landscape drip irrigation, it's about 30. And then if you get into very low flow, like agricultural drip irrigation, sometimes lower, but generally 25 to 40 PSI is about where you want to be. And so you get filters that then are going to pressure regulate so that once the water flows through the filter, that pressure is reduced to that standard amount. Very common in landscape drip irrigation is that you can get one unit that does both those functions at once. This is the most common style that you will see manufactured by Rainbird irrigation manufacturer. And that just makes things a little bit more compact. One of them does 30 PSI, one of them does 40. I believe the red one's 40, the yellow one is 30. I think usually 30 is the one stocked in the stores. And if you have kind of a long run from your valve to where your drip irrigation is going to be, you do lose a little bit of pressure through the pipe. And so you might start at the higher one with 40. And then it has the filter inside that's easy to unscrew and then just spray out with a hose or a high pressure nozzle and put it back in. And so this is generally what that looks like together. You will see the supply pipe coming from up into this part of the valve. And then when the water goes through, it then goes down to that pressure regulator and filter before that pipe goes back into the ground and over to where the irrigation system is going to be. So tubing for drip. General standard drip tubing is about 1/2 inch, it's often called 1/2 inch tubing. And it's either solid, which is meant for moving water but not emitting any water, or with the inline drip emitter lines. And so you can see here, and we'll look at other pictures, the individual little holes here, And you can see how the line is swollen near the holes. And because that's where the emitter is on the inside, it's not just a bunch of holes. They're actually a highly engineered emitter that makes sure that the same amount of water comes out of each of these under proper pressure regulation at the same time. And then the solid tubing is used either just when you need to move water and then connect to the emitter tubing, or the solid tubing is used to plug individual little emitters onto it, or to plug in the smaller 1/4 inch, usually spaghetti tube that will then go to individual emitters. And generally, for the solid tube, there'll be black tube and brown tube. They're slightly different in terms of how they are best used. So the solid tubing is mostly used as header, and header is a term for if you have solid tube running along the edge of an area and then leads to tubing that has the emitters in it, or distributing it. Comes in a variety of sizes from 1/2 inch, 3/4, and 1 inch, but in kind of residential and even the vast majority of commercial applications, 1/2 inch is what's used. Usually it goes up to PVC pipe or more solid pipe if it's going to be over 1/2 an inch. Generally, it's staked down in place with little metal stakes. We'll see a picture later, and covered up by mulch. The pipe is pressure rated to 70 psi, pounds per square inch, which means it can take that much pressure before you need to worry about bursting or the fittings breaking. But most drip systems for the drippers themselves are going to already be regulated to 30, 40 psi underneath that. And again, if you're tapping directly into it, there'll be little barbs and adapters that then come from there. And so one of the differences generally between the black pipe and the brown pipe for the solid tubing is that there's a certain fitting type, and we'll look at those fittings later, where you might need to have an elbow or a T or connect to a different piece for the black pipe, and you usually have a somewhat different fitting for the brown pipe. The black pipe is commonly sold in big box hardware stores, sometimes specialty stores. The brown pipe, the brown solid pipe is more at the specialty irrigation stores. For those of you who are in our local area, we have on that same page, cvwcd.org/presentations, where you can download the slides, a local landscape suppliers list, and you can see the specialty irrigation stores. And those specialty stores, quite honest, have a better selection of high quality drip products usually, especially when it comes into the products that are already embedded in the line, which we are going to spend a lot of time talking about. They'll also have the black tubing too, normally. And so with the inline emitter tubing, this stuff can really be used for any plant type if it's installed properly for those plants. Those individual emitters, you can see here, the brands are slightly different, but essentially this is one example of what's inside. There's mechanisms, depending on which one that you get, which also have little check valves in it, which means like if it's on a slope, all the water is not going to drain out when the valve turns off. There are things in there to help prevent, even if a little bit of grit does get through the valve, to help prevent the drippers from getting clogged up. And then the actual dripper itself, which is going to be regulated as long as it's pressure to put out a certain number of gallons per hour from each individual dripper. And the common ones are 0.9, 0.6, 0.4, and 0.26. 0.9 is generally the most common, and we'll talk about how to select the best dripper rate for your landscape later on when we talk more about design. And then also when you order it, the drippers themselves along the line are going to be spaced at different intervals. So most common ones are 12 inches and 18 inches. And the most common thing you find, even if that is going to a specialty store, is in Southern California, at least 0.9 with 12-inch spacing is generally the most common. All of the emitters generally turn off and on at the same time. You'll kind of hear the system pressure up. You'll hear some air going out of the line, and then everything will kind of start going at the same time. And this is the way to get precise and equal amounts of water over a large area and with a relatively broad pressure range. So within a regulated amount, that's not like 100 PSI down to 2. but they can compensate to some degree. The brown stuff is meant, or it's manufactured with UV stabilized plastic. So it's not like it needs to stay out of the sun like the white PVC pipe really does. However, it will last longer if it is covered with mulch. And this kind of tubing, whether it's with the emitter or just the brown solid tubing that's meant to use with this, is better used with what are called barb fittings. And again, we will look at that briefly, those kinds of fittings. And then the other kind of drip tubing that you might have is the spaghetti tubing. It does come in 1/4 inch and 1/8 inch, but 1/4 inch is the most common. And that's where if you're going from a solid pipe with no emitters to an individual stake or drippers or micro bubbler, or sometimes a situation if you're going from a solid line to a bunch of them, you might have a manifold situation like here on the lower right. And that's the smaller emitter tubing used for that. In general, though, and we'll talk about this a lot, these pieces are pretty fragile and tend to fall apart. There's a lot of maintenance issues with them. It's hard to diagnose because these are just fragile little tiny plastic pieces. And so in general, unless there's a compelling reason not to, this inline emitter line is going to be the best, most resilient way to go for working with drip irrigation. There's many fewer maintenance issues. And so there's many different ways that you might use it, but again, there's so many different ways to go that we prefer the inline emitter tubing as a more standard system. And so the two different types of drip fittings are compression fittings and barb fittings. Compression fittings are the ones that the pipe slides into the fitting, and there's a little gasket and a little ring in there that kind of clamps down on it. You slide it in and then it's stuck, basically. If you have black pipe, that black pipe generally needs to use these compression fittings. The brown pipe is better off with barb fittings, but if you make sure that the compression fittings are either the same brand or approved for your specific brown pipe, it is an option. However, the barbed fittings are going to be more resilient. And so if you're trying to figure out, like, is this an option for me, then that's another reason why it's best to go to a local irrigation kind of specialty supply store, is that the people behind the counter at those stores can help you make sure you're grabbing the right things. You're a much better chance of leaving with all the right parts than if you're just in the aisle at the big box hardware store kind of scratching your head. Some people like compression fittings because they are very inexpensive and there's a little bit less elbow grease, a little bit less muscle to push them together. However, they are less reliable over time than barbed fittings. At kind of year 5, 6, we do see these things. There's multiple pieces in all of these, and we do see things starting to slide apart or break apart. And again, with those leaks, if they're buried in mulch, sometimes you don't see them for a long time. And when it's not just a little slice in the line, but a whole fitting, it can leak quite a bit of water, and it could leave other areas of the landscape quite dry. So in general, what I always do, even if I'm working with solid pipe, is I always use the brown pipe, and I always use these barbed fittings, which essentially insert into the pipe. And then with the pressure regulation, these form a very tight, watertight seal. And then if you need to go onto like a standard PVC pipe, there's a threaded adapter to that barb. We'll look later. There's a couple of tools and tricks when we talk about installation that can help make it a little bit easier to push these together, but it is worth the extra time and effort because you will get a system that lasts longer with fewer maintenance issues. And then there's also parts intended for retrofitting or connecting existing sprinkler systems or underground PVC over to the actual drip product. So we're going to talk a lot about this approach later on of how to start with an old sprinkler system, cap off most of the sprinklers, and then convert over to drip. So you can still reuse all of your pipe in the ground. Or if you're setting up a new system and need some solid distribution tubing, like it's coming from the valve before you get to your actual drip, you can use PVC, and then you use these threaded adapters that go from the male thread that can screw into the threads on the PVC pipe over to that barb style fitting. This is the most common retrofit kit that you will see around. It looks just like a sprinkler. However, the inside actually has that pressure reducer and a filter. And so instead of needing to cut back in and do surgery back at your valve, if you're a homeowner with perfectly well functioning valves and you're a little bit hesitant to cut and start doing that PVC work, then if you have an existing irrigation system for that area, like it used to be turf or just used to have overhead spray sprinklers, you essentially can unscrew a 4-inch pop-up sprinkler, which is pretty standard size, and then screw on this thing, which looks like a sprinkler, but is really to convert, and then have the pressure regulation for and the filter for drip. And this is made by Rainbird, if you happen to have Rainbird brand sprinklers and you happen to have those 4-inch pop-ups, you actually could literally just unscrew the top part, pull out the guts and put the guts of this in, screw that back in. And then it comes with the adapter as well to either go in one direction or both directions to connect to your drip line. And then on all of the rest of your sprinklers, you need to cap them off. Now that can be, and the least expensive way to do that is, but it takes more work, is to literally unscrew your sprinklers and then reach down into that hole, being careful not to get dirt down into the actual now open line, and use small PVC 1/2-inch caps to cap that off and then bury it. However, a quicker way of doing it is you can get caps that are going to be compatible with your specific sprinkler brand, and you get a bag of those, and then you just unscrew and take the guts out, and then at that top part, like here, so this body stays in the ground, and then the top part, this just screws on and caps it. There's actually a little rubber gasket inside. Sometimes those are just loose in the bag. You need to make sure you use that rubber gasket, which just gets inserted on the underside of this to make sure you get that watertight seal. And then we'll talk about flushing later on, but there are individual little valves that are options for your system design, or if you might want to shut down part of your drip system at certain points for any reason, where they have the barbs on it and you literally just slide the drip tube over either side, and then this is a little valve that can be turned on and off. And so the other type of drip are the drip emitters. So these are the things that are a little bit more common right now for homeowners, and the big box hardware stores sell tons and tons of these, which are the individual emitters that then poke either into the 1/2-inch line. You have a little punch tool that you punch into the line and insert these on it, or they can go to that spaghetti tube. And a system that relies on these, especially when it's newly planted, to just put 1 or 2 of these at the base of each plant, I would always recommend doing at least 2, 1 on each side, minimally, is really quick and simple to install. However, most of the time, like I mentioned before, as that plant wants to grow and its roots want to go out, and after people have been walking around in the garden for a couple of years, they just don't hold up that well. And then also microspray. So we're not going to talk a lot about microspray today. Is an option. I've seen it used successfully plenty of times. And the reason why I'm mentioning it is because it runs off of that same solid tube in most situations. And so they're little sprays that usually they're on a little stake, maybe a foot off the ground, maybe 6 inches, and they just kind of spray around the base of individual plants. And so there's much less evaporation than a standard sprinkler. And it does get a wetting pattern going that's a little bit different than drip, because it is like a micro spray sprinkler. You can get them in full circles, half circles, quarter circles, adjustable ones where you can adjust the flow and the radius. They are easy to install. However, it's very tricky with those to get even and precise watering, or to know how much water you are applying. So I did an experiment one time where I had a vegetable bed, a standard like 4 foot by 8 foot vegetable bed, and a few of them. And on one of them, I put a drip irrigation system, and on one of them, I put the micro sprays and the right pressure and adjusted and everything. And then I put out little jars to check how even the irrigation was across that area. That was all with the micro spray, and it was just all over the place. So it was an easy system to install. Visually, it looked like I could really dial in where I want to get watered, but unlike a drip system, how much water was landing in each area. And then when I was done watering, the depth to which that penetrated into the soil was all over the place. And especially with the adjustable ones, you don't have that regulation like you do with the drip, where you know and then can calculate. And we'll deal with that at the end of the class. Once we have our system designed, how to know how often and how deep to water based on all of these factors of the specifications for the products and calculations. Once you have the adjustable ones that just have a little valve on it, you lose all of that. And so, not to say that you can't be successful with them, I definitely know people who are, but it's a lot more guesswork. And so we had a couple of questions come in before we will jump to our basic system design considerations. So from Benedict, are there drip systems that can be attached to a barrel of rainwater? I want to have a drip system for my small front yard and there is no faucet for it. These sorts of drip systems need more pressure than you're going to get with a barrel of rainwater. I have seen specific systems, usually using drip tape, which is more of a very low pressure agricultural style drip system, set up for like super off-grid setups like that from some online vendors. You might check Drip Depot or DripWorks are two different companies online. That's Drip Depot and DripWorks that might have something like that. But I will say, usually when you have one rain barrel filled with water, which is only about 50 to 60 gallons, unless you have a number of them or really a big cistern, that's usually not enough to, like, throughout a lot of the year, water a whole large area of the garden. And so with a rain barrel, just the reality is at the end of the day, it's generally more worth your while to just, when you have that water, like have it connected to a hose just on a trickle and move that hose around some. For most people, unless you have a really ambitious, really large rain barrel system in a climate that kind of gets constantly refreshed, it's just not worth the effort and maintenance to connect to just one rain barrel with the whole drip system. So next question from Jeff. Is there a certain order that the valve, backflow filter, and regulator need to be installed in? Absolutely. And we will look at it later, but just very quickly, since we're talking about it now and quickly to explain, valve is always first in a standard system because that's what holds the water back. Then you go into the filter because you want your water to get clean as quickly as possible. Oh, sorry, the backflow is part of the valve. If you're in an area where the valve and backflow are separate, the backflow is always like right when things hit the property. So backflow usually connected to the valve in kind of Southern California or California, then the filter, and then the pressure regulator, because you might as well have the water clean before it hits the pressure regulator, and then it goes on from there. And from Rodolfo, how many emitters can be connected to a valve? The answer with that is that depends, but we will be getting into that extensively when we talk about design. So you're already thinking in the right direction. It's not unlimited, and we'll talk about how to do that math. And I also have like some just kind of guidelines of math I've already done for you if you're going to try to skip the math part. So basic system design considerations, real basics, are starting with understanding your site, or at least the area that you're thinking about for drip irrigation. If you're going to be putting in a drip irrigation system, usually it's best to do a quick sketch, doesn't need to be a work of art, for that area, and to roughly determine the square footage of that landscape area, some basic measurements. You're also going to want to do your best to identify what kind of soil type you have on site. If you have a huge project, you can send that off to a lab, but generally that's overkill. Usually you can figure it out. And basically what you want to know is just the general category. Is it sandy soil? Is it silty soil? Is it loam, which is a mixture of sand, silt, and clay? That's a lot of our valley bottoms have our sandy loam or loam, which is great stuff to work with. Is it hard clay that doesn't drain well? Or is it super sandy and gravelly to where the water just goes straight down and dries out incredibly quickly? That's basically what you need to know. So if you already know generally, your soil and your whole area is a clay type, that's going to be fine. If you know that your whole area is kind of a nice sandy soil that's a pleasure to garden in, that's going to be fine. You don't need to get some like crazy geological survey classification thing going on. And there are different ways to tell. I will present a slide later that just kind of gives a general like by feel. Another thing that we're not going to really have time to get into, but there's a lot of resources on the internet if you want to look into it, is to do something called a jar test if you really want to kind of quantify it, where you can take just like a quart-sized mason jar or any old clear jar with a lid, fill it up like 2/3 with soil, or sorry, 1/3 with soil, fill it up to the rest of the top with water, shake it really well, like just shake it and shake it and shake it and shake it for a few minutes, and then put that jar down and don't touch it for a couple of days. And what'll happen is the heavier particles, which first is going to be gravel, then it's going to be sand, followed by silt, and finally clay, are going to, the heavier it is, it's going to sort out first. And so it'll give you a stratification where the bottom will be the gravel, and then a sand layer, then a silt layer, and if it's present, a clay layer. And you can literally measure it and figure it out by percent. And then there's kind of guides online. That, if you really want to know, is a way that you can do it. However, I'll also present some general guidelines just based on getting the soil wet and by feel on a slide later on. Someone real local, oh, hey, Karen, has asked general type in Ontario. Yeah, that's going to be a general sandy loam locally around here in Ontario. All of our local kind of inland valley areas, for the most part, is going to be kind of a loamy or a sandy loam soil. Once you start getting into, for those of you in our local area, Chino Hills clay, Chino can be clay or might be loam. And we'll talk about the reason why. But when we set up our drip grids, we will choose the volume of our individual emitters. Remember, I said 0.9, 0.6, 0.25. That's going to depend some on our soil type and how far apart we would put each of those lines. And then finally, your type of plant material to be irrigated. Are those high water plants, medium, low, or very low water use plants? And that's not as much going to modify the emitter type or how far apart those are, but mostly that's because we want to make sure we're grouping our plants with similar water needs. And so with drip, it's very easy. For example, as you can see here, it's kind of an odd shaped area with high water use, and then a small area with moderate water use, and then around the whole side, low water use. Unlike sprinklers, with drip, it's very easy to have separate areas all connected to separate valves that then run separately based on those water needs. So we want to group those like water needs together. If you're doing a landscape design, you always want to do that as well so that they can be irrigated efficiently. And that's called hydrozoning. One of the cool things about drip, though, is that you can do things like sometimes I'll put a few fruit trees in an otherwise low water landscape. And then there can be a separate irrigation system with drip that just brings extra water to those fruit trees, even though they're kind of mixed in. And so this is going to be an example. This is an aerial photo just from Google Earth of a section of our demonstration garden in Montclair that had not had much of a permanent use in this area. And we decided that we were going to do a example of what we call a habitat hedge. So it's a hedge at the edge of the property here with just one or two each of a whole bunch of different kind of shrub size, can grow into a mixed hedge of native plants that are going to be great habitat for birds and pollinators. And it didn't have a good irrigation system, so we were going to put in a drip irrigation system with the new planting. And so figuring out the size of it, and here it's 415 square feet is what we determined. You can, to get rough estimate of size, you can look up your property on Google Maps and zoom in. There's going to be a button you can click in the lower left on Google Maps to get from like a map view to actually seeing an aerial photo of the site. And as long as you don't have a lot of tree cover, it's nice if you do because you have shade, but if you can get good aerial of it like this, then you can actually right click and click measure distance and then do a connect the dots. And there'll be a little window that tells you relatively accurately the area. If it's a rectangular or very regular shape, actually measuring will always be a little bit more accurate. But for something weird like this that curves and then goes diagonal and curves on this side, it's a lot easier to use that. And it's generally going to be close enough. Our soil type is sandy loam. And our plant type was going to be low water use shrubs. So those are the things that you want to kind of think about. And so if we're thinking about drip, a couple of options. And so this is the point source drip that we talked about, where the individual button emitters are going to put water just right at the base of the plant. It requires less material and is cheaper. However, like I said, this isn't the way we went with this. This isn't the way I ever really go. And I don't consider this a long-lived system because the parts do tend to break down over time. And adjusting to those plant needs over time, this is generally not going to be a problem if enough time is spent or enough time is put onto the timer the first year. But over time, when those plants want to grow kind of wide root systems and might want less water right at the base of the plant, then this is not going to support most of our plants that well. The one exception being if you're growing mostly cactus or succulents, then you can get away with it as long as it's not getting too pooled right at the base to where it might rot. And so here's kind of the idea with that, is that this is a guide that Brandon, who I work with, our conservation specialist, found online for, if you were going to try to work with these, what you might need to do. So for small shrubs, 2 or 3, large shrubs, sometimes you'll see 2 or 3, but really because these plants as they grow want even water more at their drip line. So they're trying to get water at the edge. Generally, oftentimes you'll see even more. And then those bubblers that are adjusted 0 to 13 gallons per hour. That's such a large range. So then you'll also see these general guides, like this breaks down to where there's no real accurate way to predict this. So, they're recommending 90 minutes for 0 to 13 gallons per hour. Well, if it's set to 6 gallons per hour at 90 minutes, that's very different than 13 gallons per hour at 90 minutes. So I'm not really comfortable with these systems. Not to say that if you've been successful with these, you can't do it. But in terms of providing general best practices, things get real kind of iffy here, and they tend to fall apart. And so, for example, for a large canopy tree, just to have 2 drippers, most of the root zone is going to totally stay dry. That's not going to keep that tree that happy or healthy. If you look at real best practices, if you're trying to maintain this, this is basically what you would end up needing to do over time. Is when the tree is small, maybe you're just 1 dripper on each side. But as it's starting to develop a huge root system in the zone of where it wants to get its water, you need to be adding more and more and more and more. And nobody actually does this. And especially if you're dealing with trees or larger shrubs in areas like in Southern California, where we get the Santa Ana winds, if you only have a couple of little drippers near the base, that's where the root system is going to be trained to stay. And then when we get those winds, especially trees, they're going to be more likely to fall over than if we've been giving an even watering to the whole root zone with a drip grid system, which we'll look at next, to where the roots have been trained to go out, find water, and establish more in their natural pattern. So, last thing I'm going to say about this point source, because a lot of you will probably already have point source at home, is if you have been successful with it, I am not saying that you absolutely need to go out now and tear it out. If you already have, or if you're going to look at all of my advice and still decide to use point source emitters, right here, it got cut off. I'm going to exit this briefly to make sure that I can post the link in the chat. So here I'm posting in the chat is the link to the best, kind of most extensive guide to using and then how to set the timer for those individual button emitters that I have seen put together. That is from a water conservation collaboration with a number of water agencies out of Arizona. And they do a bunch of things under the name Water Use It Wisely. And that's the best I've seen in terms of trying to present how to use that long-term. And in Arizona, where there is a lot of kind of more sparse landscapes with kind of desert style gardening and succulents, which can take having a pretty constrained root system in many cases, it's a little bit more viable. I generally don't recommend it for native and Mediterranean plants. So just wanted to provide that resource. So what I always install with drip irrigation, consider it a more professional system because it's more resilient, it's more long-lived, and it puts water where the plants might want it long term, or where the plants are more likely to want it long term. And you can actually easier calculate how long and how often to water for your plant types and your area. Are inline drip grids. So again, this is where you get the rolls, and for homeowners, generally 100 or 300 foot rolls at the most. They also sell them in 500 and 1,000 foot rolls. However, those sometimes, especially the 1,000 foot rolls, those are really meant to go on these reels that then professional landscapers have the equipment to pull that out, not turn it into a mess. 100-foot rolls for homeowners end up being kind of the most manageable to work with in many cases. And so you get it in a roll. Usually right when you buy it, there's kind of plastic around it and it has all the specifications of the line that you're buying, but this is the stuff. The actual opening, some brands it looks more like a slit, some brands it looks like this. The shape of the plastic thing embedded in it might look different depending on the brand, but it's basically this. One quick installation tip if you are working with this stuff that I don't want to forget. Most brands these days, it does come covered in shrink wrap, and then you also have these plastic bands around it. The black here might be white. If it comes covered in shrink wrap, don't remove all of that when you're getting started. How that's supposed to work is that you can just cut with the scissors carefully so you don't cut your drip line, the inside of these bands, leave all that plastic wrap on it, and then you start unrolling these from the inside, which makes it a lot more manageable. The whole thing doesn't uncoil on you at once. If you just take everything off, the whole thing's going to start loosening, coiling. It's going to be more likely to get tangled. But if you only unroll it from the inside, leave it in that plastic, it's going to be a lot easier to work with. And so like I mentioned before, with this brown tube, you use these insert or barbed fittings. And there are many different brands of this stuff that are all good. For homeowners who have not done much of this before, because there is a little bit of elbow grease, you kind of push and twist a little bit till these get inserted. Rainbird does make a fitting. Their fittings actually have this little, you can see here, plastic extra ridge on it. And they have what's called an insertion tool, which is purple, looks like this. This is going to be something that you get at a landscape supply store, specialty store, generally not at the big box hardware store. And that extra ridge allows those to snap into this tool, where then you can put the palm of your hand against the back and it gives you more leverage. It makes it a little bit easier to put them in. And then you can also use these little side pieces, which your fingers go into for that leverage, to kind of, when you cut the line, kind of loosen the opening a little bit before you snap it in and push it in. So for homeowners, if it's your first time, those Rainbird fittings do work pretty nicely. And then this is just one manufacturer's kind of look at the engineering that goes into each of these emitters. And so here, this picture turned out a little bit grainy, but for areas like this, I would never use spray. There's between how narrow it is and the curve here, you're always going to end up with a lot of water on the asphalt, which can cause the asphalt to wear prematurely. This is totally meant for drip irrigation. And so for a small area, we'll talk about how to figure out the spacing in between each of these lines later on. But basically what you can do is you can just kind of curve it in and out. But with those emitters, for example, here, probably every 1 foot, by the time those all go, the whole area gets pretty evenly wetted, like except for, maybe the little corner out here, but that's okay. For a large area, might look something like this. And with drip, especially if you have sandy or more well-draining soil, when you run your system, this is what you might see at the top of the soil. You might never see the whole area get wetted. You might see individual circles, but as that water goes down through the soil, a few inches down, each of these circles is going to be wider. And by the time you get like 9 inches, a foot down into the root zone, if you've set your system up right for your soil type, it will be completely wet. So the root zone does get evenly wetted. Here's another example picture. If you are doing a landscape and you're going to have pathways or areas that are not going to be planted, are not going to be root zone, you don't need to cover those. And so one of the nice things about working with drip as opposed to sprays, you can have areas that curve like this. And because the pipe is flexible with the different fittings, you can do your best to do that. You can see how they worked around the valve box right here. If there's any other objects in the way, you can kind of work around things however you need. And most of the manufacturers have online for their product, like a very detailed installation manual. Some of it gets extremely technical, might be worth looking into, might not be. Here you can see here they don't have the anti-siphon valve in the example because this was just an example for an area where that's probably not the most common thing or a commercial landscape, but for your homes in California, you probably have that anti-siphon valve and your filter and pressure reducer. And then usually it'll go to PVC pipe until you get to your local area where you're going to have your drip. And then for a small area, again, you can just take that tube and go lay it out. You're going to have normally, depending on your layout, every 4 to 5 feet, you're going to have one of these little staples. We'll see images of them later on. You can optionally get something called an operation flag. That's something that pokes into the drip line. Sometimes they're called a tattletale. And that is something that pokes in. And when the line is pressurized, it kind of shoots something up. It doesn't let water out, but it just tells you that it's on because it doesn't make a lot of noise when it's on. They're not a bad idea. You don't always have them put in. And then on the far side, that's where you have that flush valve, that little valve that pushes in. And that just allows you to immediately after installation, or every once in a while, every 6 months or a year, you open it up and turn it on. And just if there's any junk or debris that has had accumulated in, it shoots that out. And there's different ways you can do that. Sometimes people just have an adapter and a little screwed on cap, but I like the valve because it's really easy to just open and close it with one person, and it doesn't make a big mess when you do that. If you are just one person and you turn things on at the timer and then you just have a little cap that's unscrewed, then you don't know, sometimes you're shooting maybe more dirt into the line when it turns off. So the valve is nice because you can just open it and close it yourself quickly. And then just one quick note here, we'll talk about it later, but you always want your drip to be at least 2 inches. I normally go more. I normally go up to 4 inches away from the edge. So any path areas, concrete walkways, decomposed granite walkways, or anything like that, sidewalks, you always want it to be a few inches off. And so now we are starting to get into the details of design. Some of this is going to get a little technical. Try to absorb what you can. Remember, you'll be able to download these slides. This is being recorded, so you can refer back to it. And just absorb what you can. So here is, if you're getting into design, especially if you're not doing just a small like planting bed, but you're thinking about like an area that used to be a lawn. One thing to remember, you can only put so much water through a pipe of a certain size. And there's a few reasons for that. But normally, before you get into actual situations of the water supply, like if you're on, city water, that like coming through the pipes, you're running out of water. Normally not what the barrier is going to be. Sometimes, like if you have an old rusty galvanized pipe system where there's issues, sometimes that's it, but normally that's not it. Normally the restriction is that the more water you put through the pipe per minute, per hour, however you want to think about it, the more irrigation demand at any given time is needing to go through that pressurized line, the faster that water needs to travel to meet that demand. So if you think about it, if you have an irrigation system with 3 sprinklers on it, there's a certain amount of water that needs to go through that pipe to meet that demand that occurs when the valve opens up and then the pressurized water flows through. Instead of 3 sprinkler heads, if you had 15, that's going to require 5 times as much water to be flowing through that pipe at any given moment. And so that water needs to travel faster. Over a certain speed, that water is traveling fast enough that when it changes direction, when it hits the fittings, the elbows, all of the little different components within your irrigation system or that are holding things apart, it can be at a speed where it can start to damage the system and over a long time cause breaks. And that's known as water hammer. So same thing, like if you all know those houses, if you don't live in one where like there's the older plumbing and you have water flowing and then the water turns off suddenly and you hear everything shaking, that's water hammer. That's not good for the system or for the pipes long term. So that's generally our limit to how much water you can put through the pipe, which gets back to how many of these drippers or how many linear feet of this drip line can you have connected to one valve. It's based on the size of the pipe and the size of the valve. So generally in our landscapes at home, we're using 3/4 pipe as kind of a standard, or you might have 1/2-inch pipe, especially if you're converting from a sprinkler system. It's like the far end of the sprinkler system. Or if we're working all with the drip line itself, that brown tubing or that black tubing, that's 1/2-inch pipe as well. So for 3/4-inch pipe, the rate of water flow through that pipe should stay below 8 gallons per minute, because beyond 8 gallons per minute, the water's traveling fast enough that it can damage the pipes. For 1/2-inch pipe, whether that's PVC pipe or the drip pipe, you want to keep that water flow below 4 gallons a minute for the same reason. And so we will talk about what that means. Basically, all of this is, and there's charts if you really get into irrigation design. I'm not even showing those because that makes it complicated. I just kind of presented for the 2 main pipe sizes that you're going to work with, what it is. But if you're for 3/4-inch pipe, below 8 gallons per minute. And then it's always a good idea to test your water flow, especially if you are on an old property where you know there's some problems with your irrigation system and you don't think you have enough water flow. You want to test it. I generally will test it anyways, just to make sure. And so basically, if you know that 8 gallons per minute is going to be your maximum, you can test your water flow by just connecting to a hose bib with a hose. And if your flow exceeds 8 gallons per minute, you'll be able to have plenty of water demand for your system. And generally, most properties, that's going to be fine. But generally, it's pretty easy. If you have a 5-gallon bucket around, it's going to be 5 gallons. So you can turn your hose open completely and see how long it takes to fill that. And that'll tell you 5 gallons. And then you can do some math to convert it to 8. But basically, you know, if it takes less than 30 seconds at full blast to fill this bucket, you know that you are going to be plenty fine, because you'll be able to be beyond that maximum that you want for your system design. And then the other thing that you want to know going into it, in addition to your flow, is your water pressure. We already know for drip that we are going to need to have that pressure regulator and filter. There's a couple ways to go with water pressure from there. If you are adding this on to an existing irrigation system with automatic valves, and everything has always seemed to be working fine or well enough, at least in terms of water flow and water pressure, your valves don't tend to be breaking or anything like that, then generally just adding on that filter after the valve is going to be okay. However, it is best, so kind of presenting best practices, to test your water pressure with a pressure gauge that you can get at the irrigation supply store. Usually, if you're kind of installing things from new, or if you are thinking about running your drip system off of a hose, feeding it from a hose bib and not off of an automatic valve, it's going to be too high if it's not already captured by a whole house pressure reducer. So the whole house style pressure reducer are those brass ones. I'll show a picture in a little bit. And generally, like, those are on a house. They're not always there, but they're generally on a house before the water goes into the house. It's about a 50% chance whether your landscape irrigation water supply is already captured by the whole house pressure reducer, just depending on how the plumbing was originally installed for the landscape. Probably greater than 50% chance from what I've seen is it's not captured. You will need to have a pressure reducer. And so this is actually my house. When I first moved in a couple of years ago, there was no pressure reduction, and I'm in the city of Pomona. Water pressure is really high. So you can see here, just at the hose bib coming off the back of the house, 150 PSI. That's crazy high. That is so high that that can cause problems for the actual sprinkler valves as well. So I actually needed to install a second whole house style brass pressure reducer just for my irrigation system. The best way, if you're really going to be doing it, investing for your whole site, to really test things, and then you will know for your specific irrigation system, and you don't need to worry about, is it captured by the house, is it not captured by the house, is if you have an existing sprinkler system with like a standard sprinkler nozzle, then you can get a pressure gauge where you just quickly unscrew your sprinkler nozzle, this part, and then you screw this gauge, and it has this little T-piece right to where that sprinkler nozzle connected, and that'll give you an accurate pressure like right at your actual sprinkler. So this is a picture from after I did all the pressure regulation, set up my irrigation system, and then tested. And down on this system, I was just below 40 PSI, which was perfect range for this sprinkler. So it's a little complicated, but long story short, if everything seems to be working for your irrigation system and you already have the automatic valves, chances are you can just add on that style pressure reducer and filter. These things are rated for the inlet pressure, so the pressure coming into it, to be up to 150 PSI. So that's pretty high. Occasionally we see higher than that, but that's for those. If you have 150 PSI and higher, and generally I like to think if I have over 100 PSI, I'd rather be safe. I will actually consider adding in one of these, but you need some plumbing skills for that, or you might need a professional plumber. These are a little bit more complicated to install. And then finally, the spray to drip retrofit kits. These are the ones that just screw in where your sprinkler used to be. Important thing to know is that those are only really rated to work up to 70 PSI for the pressure coming in. And so if you test and you're at 100, 150 PSI, you might need to add this at the valve instead of doing the quick and easy replacing the sprinkler, because that only works for up to 70 PSI. So I don't want to make this too complicated. However, the being off with the pressure is one of the main things that one of the main reasons that we see when we go out into the field to help people of why they're having issues with their drip irrigation system. So it's worth spending some time on. So here are my general recommendations. If you test your pressure, especially if you test your pressure at the sprinkler and it's 30 to 40-ish, you're going to be fine. You still are going to need the pressure regulating valve and filter after the valve, or the retrofit kit. If your pressure is 45 to 100-ish, you're going to want this up to 70 PSI for this. If you're really high, up to 100 or so or higher, definitely if it's 150 or higher, you're going to need one of these. And if you're not comfortable doing plumbing work and really cutting lines, because normally this would need to be installed before the valve, not after the valve, that's something to call a plumber for help with. And so that's a bit about pressure. If you have questions about that, please type them in because it's a really important topic. The next thing we're going to talk about as something you need to understand for design is you're going to want to match the product that you buy, at least in terms of the emitter rate. And so you will be able to buy the same product. So for example, here, this is a clip from the specifications for the Rainbird brand XF series drip line. And we'll talk about kind of drip line purchase options. But for whatever series and brand, they're going to sell the same product and different emitter rates and different spacings down the line. But you're going to need to know which one to select. And that is generally based on soil type. And here is why. So this is just an image of roughly like what it would look like if the same volume of water, so we can just say 10 gallons. If 10 gallons of water was applied to one spot in sandy soil, loamy soil, and then clay soil. The same volume of water in sandy soil because of the space in between the soil particles and the natural properties of the soil, is going to spread out less wide, but deeper. The same volume of water in loamy soil, which is a combination of sand, silt, and clay usually, sometimes different amounts, is going to go a little bit wider and a little bit less deep than in sandy soil. The same volume of water applied to one spot in clay soil is going to go much wider, but much less deep. And so if we are trying to get an even deep soak in our drip grid irrigation system, that means that we will probably need to put out a faster volume of water into one spot in sandy soil so that we force that water to spread out a little bit more. And we know that it's going to have no problem just trickling down over time. But in a clay soil on the other side, we're going to want our emitters to go slower because it's going to go wide. And then if too much water is coming out too quickly, it's going to start to pool up on the top and then might start to run off or just not accumulate evenly. So we want to be only applying water as fast as the soil can absorb it in a clay soil. So we're going to have emitters that put out water less quickly. And so for very rocky soil, the question just came in, you're going to go with generally with sand. And you'll see here, so I'll explain it and then I'll mention for rocky soil what to do. But generally you're going to start on sand, or sometimes they'll have a rocky one here, but generally it's going to be sand. So each manufacturer will have a chart for their product that looks something like this. And if you're looking it up online, you can kind of have the specifications, or sometimes if you go to the specialty irrigation store, they can help you with that. You can say, I know I have sandy soil, I'm doing a drip grid, what do you recommend? They can help you on that. And they probably have this memorized, so they might not refer to a chart. Not at the big box hardware store though. They won't know how to help you with that. And generally they're not going to have all those options. So you're going to have your soil type, usually sand, loam, and clay, your emitter flow rate, and depending on the product, some of them have higher, some of them have lower, some of them will be 0.9, some of them will be like 1.1, but generally it's going to group pretty close to this. Clay, you're generally going to be down around 0.4 gallons per hour, loam 0.6, sand 0.9. If you have a sandy loam, like for those of you in our local service area, kind of our valley bottom areas, Ontario, the loamier parts of Chino, Pomona, Claremont, all that, it's a sandy loam, but you're generally going to go with sand. Generally that's 0.9 gallons per hour. This is for like a heavier loam, which we don't have as much in our area. And then in addition to the actual emitter, you're going to choose what the spacing is down the line. So for clay, it might be up to 24 inches. For sand or sandy loam, 12 inches. And then that true, like real mixed loam in between. And then the final one, drip line lateral spacing. That's just a fancy way for saying the recommended distance between each of those lines. So when you're laying out those lines on the ground, how far apart should each line be to get an even water if you're relying on this product on that soil type? And so for what we most often have around here, which is sandy loam to very fast draining soil, you have 12 to 18 inches. And so this is where it gets into the rocky soil. So typically here, and most of the projects I'm involved with here at our Waterwise Community Center Garden in Montclair, we have pretty sandy loam soil. My house in Pomona, for people in Ontario. Generally for Waterwise plants, you're going to have the line with the 0.9 gallons per hour emitters, 12-inch spacing already embedded down the line, and you will space your lines as you lay them out about 18 inches apart. That gets a pretty good even watering. If you have extremely rocky soil or gravelly soil, you're going to then stick to that 12-inch or that closer emitter spacing because you're going to need that, or that closer line spacing, because you're going to need that extra help because the water is going to want to go more straight down. Then clay, you're going to be 18 to 24 inches. In general, if you're going with that 24-inch emitter spacing in clay, I'd probably start closer to the drip line spacing in between them at about 18 inches as well, as a general starting point. You always can lay out once, if you're doing your whole yard, lay out one small area first and test it out, dig in the soil some and see what you see for your specific situation. And then this is the slide that has that general guide. Here, what you can do. Get some soil up. If you have clay, when it's dry, it forms very hard clumps. When it's damp, it's flexible, almost plasticky, and you can mold it into shapes. Like, maybe I can make a little pot out of it. It might have a little sand, might have a little grit, but it's very slick. And also when it's wet, it will leave like a soily film on your hands. Loam is going to, when it is dry, be a clump that breaks apart very easily. And when it's wet, it forms a lump, and you can feel a significant amount of grit in it. True sand, the soil particles are loose and sandy. And sandy soil, it's usually not like beach sand. I mean, there's some smaller particles, but when it's dry and you dig it up, it's really going to want to fall apart in your hand. And when it's damp, it's going to form a lump. You can make a ball, but if you squeeze it with your hand, it's really still going to kind of crumble and fall apart. That's just a general kind of guideline. And so before we move on, I had a lot of questions come in. So let's talk about that. Okay, so from Kevin, can you speak about the additional thing you need when your valve is at the bottom of a slope? Yeah, so to prevent the water from coming back down. So what you generally need is called a check valve. There's different types of check valves, different configurations. It gets a little bit more beyond what we can get into now, but what I would recommend is take a few pictures of your situation, your valve, your slope on your phone, go to the local landscape supply store and say, I want to prevent backflow in this situation. I heard that I probably need to look into some sort of check valve that's going to be installed along the line to prevent the water from flowing back down. What would you recommend? Again, for a landscape supply kind of specialty store, and they can help you with the landscape supply stores, or basically landscape supply store, irrigation supply store. The people there normally serve contractors. They are much more knowledgeable than like a normal hardware store that sells irrigation stuff. And generally, as long as you don't show up there at like 7 a.m. when all the contractors are getting their stuff for the day, if you show up mid-morning, early afternoon, they generally will make the time to, listen to your questions and help make sure that they give you, what you're looking for. And that comes to when you're figuring out drip parts for your projects as well. You can go there with your parts list, or I would also recommend kind of drawing out, your plan, and you can ask for their help, making sure that you purchase everything that you need. Okay, so let's see. So from Dr. Igor, if I check the water flow rate at the house faucet being unreduced, would the flow rate be the same after installing the pressure reducer? Okay, so how are flow rate and pressure connected? Good question. So they are connected. So like if you have super high, like 150 PSI pressure, it will be shooting more water through the line. However, once you get it down to the pressure that we are looking for, kind of that 40-ish PSI, that's still not going to be causing like a huge restriction. So to keep it pretty simple, generally, if you're meeting your water demand, easily from that test before pressure reduction, then after pressure reduction, in the vast majority of cases, you're still going to be fine. Really, where you get into problems is if for some weird reason, sometimes happens to like people out in the country on a well, or if you have really old pipes that have corroded on the inside and you're having flow restrictions, that's generally where you're going to fall into that sort of situation. So from Lynn, can you mix flow rate emitters on the same line? If you are using the inline drip grid, no. And when we get into kind of how to schedule towards the end of the class, you'll understand why. If you are using button emitters and first you're doing some plants that are going to need more water and some parts that are going to need less, yes, you can. but then really understanding and dialing in how long to water for kind of becomes a bit of a mess. So like physically, can you do it? Yes, but it becomes a little bit more complicated. If you're doing those button emitters to where you're going, if you're working with button emitters, you're going to be calculating it kind of differently. You're going to be figuring out gallons you're delivering to each plant, not how you're delivering water to the whole root zone. And so it's a bit more viable. And again, for that, I'd go to that link of that guide that I posted in the chat. But for the most part, for these drip grids, you're going to stick with one thing, and you're doing it for your soil type. And then how long you run it is going to be for your plant material in each zone. Okay, and the last question for now, before we talk a little bit about products, is Suzanne, what about adding a place to add fertilizers to a drip irrigation system, kinds and placements? So I will say that I don't do that. That's very common for agriculture, and it's called fertigation. There are all sorts of different types of systems for that. I grow a lot of vegetables at home. I have agricultural style drip systems, but I still, for various reasons that we could talk about in, could be join us when I'm teaching an agricultural kind of focused class, we can talk about, but I tend to go with organic granular fertilizers anyways. But if you do want to add liquid fertilizers to a drip system, and again, if you're using Water-Wise or California native plants, you might not be, they don't need any fertilizer anyways, because they're used to growing in very lean soils. But you're going to want to look at fertigation systems, and the best way to look at your options and information about how to install them, because it might be different based on your system, is going to be with the suppliers. So you might look at Drip Depot or DripWorks online, or also Peaceful Valley Farm Supply as potential suppliers to start with. But generally, it's going to be after the valve. You're not going to want to have it before the valve, because before the valve, the system's always pressured. It's going to need to be after the valve, which means that you're limited to one valve for that installation, or having to uninstall and reinstall it. So that can be kind of a pain if you have a really varied backyard. And then the question about spacing on the slope, I have a slide for that later on. So just hang on with that. Okay, so there are many different manufacturers of drip irrigation products. I will say that the landscape supply stores tend to have way more options and generally sometimes better quality than the hardware store. The two most common high quality brands that you're likely to find at the specialty supply stores are Rainbird and Netafim. And then they have all sorts of different lines. And so if you're going to refer back to this, these are just the most common kind of high quality choices. They also have like bells and whistles added premium products that have like extra little things to have even more improved prevention of roots ever being able to get into the drippers, which is generally not a huge problem, or, you know, always the newest and greatest things. Sometimes they're not that much more expensive and you can go for them, but these are kind of tried and true. I, as well as many other landscape professionals I know, have used both of these, you know, for very, very long. So you can't go wrong with those products. That's not to say that other ones aren't fine, but a lot of times people ask, like, I just want something to start with to go with. So those are some recommendations. And then for general notes, we already talked about this, but I put this on the slide because in our local area, this is what most people are dealing with. Loamy, sandy loam to sandiest soil, buying the product with 1 foot spaced down the line emitters with 0.9 or 1.0 gallon per hour emitters, when laying that out about 18 inches apart in general. The last two parts are going to be for layout general options. If you are in a different soil situation where you're going to be having a different kind of drip, on the installation manuals for those products, which are going to be available on the manufacturer's website, you can find charts as well. But because in our area, this is really the most common, I did this math for people who might be doing this. Off of a 3/4 inch size, so that would be a solid pipe header, So one valve generally is going to connect to one header in a larger area. So you're going to have a 3/4 inch valve, common for home irrigation. That's going to lead to a 3/4 inch pipe. Coming off of that pipe, and there'll be lots of pictures coming up, coming off of that pipe, you can run approximately 800 linear feet total of this drip line based on how many emitters that's going to put out. So it kind of did that math for you, or kind of pull that off of the chart for you. If you're having a setup like this, you can run up to 800 linear feet. Doesn't matter what pattern they go in, or if your space is rectangular or square or kidney shaped. 800 linear feet total of that, just based on how many gallons of water demand that creates. If you're using only the 1/2 inch drip line, like you're doing a smaller zone where you weave everything together, just using that 1/2 inch drip line and it's connected back to itself, and you don't have that 3/4 inch solid pipe header, you can do 248 linear feet of that. And this isn't going to make that much sense right now, but it'll come back. You'll kind of have that aha moment when we look at pictures later on, and this will be here as the reference. But if you create a loop with your drip line, instead of having to only travel in one direction, which makes the water go really quickly, the water can actually travel in both directions, which lets it go a little bit slower. So oftentimes, even if on the surface, everything is connected by just 1/2 inch drip line, as long as it's being fed by a 3/4 inch pipe to get the water there, if you create the loop, you can actually get a few more feet out of it, and it jumps up to 313 linear feet. I will save you the math, but that just kind of is a way that you can get a little bit more out of it, is by making sure that drip line kind of loops back into itself. And we will look at pictures of it. So hopefully that will come together later. And this is basically, for those of you who might want to go back to it, this is one of those charts which just basically shows you can do the math yourself. It's not that complicated. If you have, for example, 100 feet of a drip line and it's 0.4 gallons per hour, you can do the math to convert it to gallons per minute. But this is just the maximum amount of water flow pipes of different sizes can handle. But the one thing to keep in mind is that when we talk about drip, things are gallons per hour because it puts out very slow. When we talk about pipes, it's gallons per minute. So if you are going to do all of that math and not rely on kind of my general guides, then remember that to get from gallons per minute to gallons per hour, you're going to multiply by 60. So it's critical math if you're really engineering that from scratch. But in general, for most people, you can use the number of feet. And then this is just another example. So the guide that I showed you earlier there is from the Rainbird brand. And so here is the Netafim brand. And so you can see things are a little bit different depending on which particular product, but there's going to be a similar chart. And here they broke it up between sandy and coarse. So if you're that person with that real gravelly soil, here you can go to coarse. And here, instead of giving a range for sand like the other one did, they just give 4 different categories instead and more concrete recommendations.
Okay, we are back. So we're going to get started with a question that came in from Rodolfo. How do you decide which type of emitters to use for containers? That's a good question. And because we don't get into it really much later, I will answer that now as people are getting resettled. So drip can be a good option for containers. And there's no perfect answer, but I'll tell you about your couple of options that will work. So the 1/2 inch drip line, like we are talking about for these sorts of systems, although it is quite flexible for most containers, just doesn't have enough of a bend radius. It'll tend to kink if you're trying to coil it around containers. The individual button drip emitters, though, because potting soil is so porous, the water really tends to go just straight down. So I generally don't like those either, but there is available. And oftentimes this is available at the big box hardware store, sometimes at the specialty stores. You can get a 1/4 inch drip irrigation line that already has the emitters embedded into it. So it's kind of the same structure as the 1/2 inch line, but it's a 1/4 inch line. I don't recommend it for landscape because it's not quite as resilient, but it does have a much tighter radius. So you can put that in a pot and you can kind of coil it around to where you're really making sure that the whole root ball of the pot gets wet. And then in terms of how long and how often to run it for a pot, there's so many different things from your pot type. If it's a porous clay, it's glazed, it's plastic, to your potting soil type, to the plant, to how much sun everything's in, that really the only way to do it is essentially you can, just by trial and error, see how long it takes once you start running that drip in the pot to where water is starting to come out the bottom, and then you know the water is penetrated. We'll set your time. And then for how often, it's just going to be based on observation. It's going to change a lot depending on the kind of year. But in general, for most potted landscape plants, at least, the top inch or two of the soil can dry out after the plant is established, but you don't want to let it get bone dry, even if it's a low water kind of plant, because there's just not that much of a root area. And then that is one of the few areas also where I would potentially use micro sprays, and I have in the past. These days, I normally would go for that 1/4 inch drip line coiled, but micro sprays, as long as the foliage of the plant is not blocking it, and they can actually, sometimes it's like one on each side of the plot, get a good even spray, you can use those as well. And then, okay, comment from Karen. Yes, one day we would love to put together comprehensive materials list, calendars, sequences of chronology, and all of that. And thank you for asking for that. Haven't been able to have the time to pull together that resource yet, but certainly that is something that we would love to pull together as a supplement for the workshop in the future. And if we ever create that, it will be announced in our newsletter. So it's another reason to sign up for the newsletter. Okay, so let's start to take this and actually look at some systems with this knowledge. And so remember, this is our 15 square foot bed where we are going to be doing our drip grid. We know that we are going to be doing some sort of long layout, and based on our soil type, we know that we're going to be buying drip line that has 0.9 gallons per hour emitters spaced 1 foot apart down the line and 18 inches apart across from each other. So we can start to, based on our measurements of the area, understand how many lines we'll need and figure out how many linear feet that is. And so if you are working with that 0.9 gallon per hour material, then connected to that 1 foot spacing, if we are using all 1/2 inch line, we know that it's going to be a maximum of 248 linear feet, or if I did some of this math for you, covering an area of about 375 square feet. Beyond that, you're going to need a 3/4 inch header, which can provide off of 1 3/4 inch pipe up to 550 linear feet of that specific drip line. That's 0.9 gallons per hour, 1 foot spacing, or that can cover up to about 825 square feet. And that's also a good reference, because generally in residential situations, we're going to have a 3/4 inch valve that goes to a 3/4 inch line, which means that for this kind of drip line, each valve can do about 825 square feet of landscape in this kind of drip grid style. So make sure that your sketch is accurate, and then you can check the manufacturer's charts where you can pull this information as well if you're using a different kind of drip line. But that's really the professional way to do it, to understand you are going to have sufficient water supply and that the water is going to be flowing. And so here's just some visual examples. This area, which we re-irrigated, we put in an improved drip grid irrigation system in our demonstration garden when we were renovating the planting. This area off of 1 point, so this is basically a 1/2 inch connection. So what might be achieved by just unscrewing a typical sprinkler. And you can see what we did here. This is a relatively small bed. This is probably 200 square feet or so in the bed. And so we could come from 1 point of connection, and using our different fittings, we can basically lay things out. We went in a couple of different directions just based on what was going to be easiest for the layout. And you can see we aimed for it to be roughly 18 inches apart. And so you get to, in real landscape, sometimes some narrow areas. Generally, I'll have things be a little bit closer rather than a little farther apart, because I'd rather have it be a little bit moister in one area than too dry. And it all kind of around the edge comes back together. So this is just fine. And then there actually is that flush that I talked about, little flush valve back behind that rock. So this is a small area that can just connect all from one part using only the 1/2-inch line. If there was a larger area, then here's an example of what it might look like coming off of that 3/4 inch line, where you would have a manifold. So instead of it all connecting back to 1/2-inch line, you can have the greater flow from the 3/4 inch line by having the PVC pipe. And then it goes to the PVC pipe, which gets glued together, has at the T, these T's are glued on two sides, and then the part coming out is threaded. And so screwed into that thread is the adapter that goes to the barb. And you can ask the people at the landscape supply store about all of these different parts to make sure that you get all the right stuff if you have to do the setup. And that allows a greater water flow across this side, which then by the time it goes down to the 1/2-inch pipe, still remains less than the total linear area or amount of flow that the 1/2-inch pipe needs. So hopefully that makes sense. Small area can all be fed by the 1/2-inch pipe. Larger area, you need what's called the header, sometimes manifold, to then have the greater flow through the wider pipe before it hits the smaller pipe with the emitters. Here's a picture of what that looks like in the real world. So here's the PVC pipe, and then every 18 inches it goes to that. So it does take more work to put in. And so this in the real world is the area that you saw on the Google Earth image. And we will go through some slides kind of step by step showing how this went together. But for the header here, instead of using PVC, we use for this situation a product called Blue Lock, BLU-LOCK, which is an alternative, which it comes in a 3/4 size. It can put the amount of water through as a 3/4 line. It's a little more flexible than PVC. It's made out of polyethylene. It's basically thicker walled and more rigid than drip and larger. It does have fittings with a little gasket that just push together instead of having to glue it. And it's just a little faster and more environmentally friendly. That's BLULOCK, and we'll talk about it a little bit later. It's something that you need to special order. You can't just go to the store and buy it, but it's very easy to work with and pretty friendly if you are not comfortable with gluing. And so a brief side before we go more is, what about if you just have some trees to water? And so what you can do is for trees, you definitely don't just want to leave a couple of those button emitters right at the base. You want to, for each tree, kind of anticipate what the canopy is going to be, and water, a lot of your water is going to be right at the edge of the canopy. And so as the trees grow, you might need to add more on over time. Or if it's a fast growing tree, just anticipate where it's going to be from there. So this is a real world example. If we're not having plants all the way underneath in between the trees, you might have your header. If you only have a couple of things this small, again, based on the linear feet, you might choose to just have the 1/2-inch line, or this could be coming off of PVC pipe if you're doing a bunch of trees. And then what I like to do is, instead of these concentric circles and a bunch of different fittings that you have to push together, I just do a spiral. And that also makes it really easy if you need to change it over time. You can unspiral, you can rechange things, you can add more length onto it, you can unspiral, for example, even if it grew wider out and this wasn't a pathway, this was just all garden. If this tree got twice as big, you can unspiral this, add more line on the end, and then respiral in a bigger pattern. And still, this, because we're doing our 18-inch spacing, still aiming for about 18 inches apart. And then our flush then is just at the very end of the spiral. And so you still do your same spacing based on soil types. And then the spacing, or the rings, are trying to get to the end of that canopy. And so for the person who asked about slope,
here's the slope layout generally. If you have just a gentle slope, you don't need to worry about it. But if you have a steep slope, what you do is the main part of the slope, you will do it based on the normal recommended spacing. What you need to do with the slope, though, is keep an eye on the fact that you are not watering for so long. This is going to be on your soil types. So it's going to be site specific, but you need to keep an eye on how long you can water before you start to suspect that there's kind of runoff along the slope. And so that might mean that if you total need to run for an hour, that maybe you might need to run for 20 minutes, let the water soak in some for an hour, run it for another 20 minutes, let the water soak in some for an hour, run it for another 20 minutes. And within your irrigation controller, most irrigation controllers either have a function called cycle and soak, where you can automate that by telling it how long to wait or the maximum runtime for the zone, or they have what's called multiple start times, where instead of saying an hour, you can say 20 minutes and have it start 3 different times at different times. And then if you have a long slope, basically the way even underground the dynamics of the water are going to work is that underneath the ground at the base of the slope, it will be a little bit wetter. And so the recommendation is that for the top 2/3 of the slope, you stick to your normal spacing, but the bottom third of the slope, you can increase by about 25%. In the real world, for general small slopes, people generally don't worry about it and it's fine. But if you have a big one and you think you're going to have water kind of that's going to want to accumulate at the base, that's something that you can do. And so remember, the things that we talk about, emitter spacing is the spacing in between the individual emitters already embedded down the line. Row spacing is the spacing in between the lines. So like we've been talking about, common 12-inch emitter spacing, 18-inch row spacing. And then I do want to cover a little bit more about the retrofitting process. So that's when you're going to be moving from a existing sprinkler system and converting it to drip. In most cases, if your existing sprinkler system is functioning well enough in terms of the fact that the underground piping is in good condition, even if the distribution spray of the water is not great, as long as the underground pipes are doing pretty well, you can normally save everything that you have underground, not need to do a bunch of trenching, and cap most of the sprinklers. And then in just 1 or 2 places, put this retrofit kit in that we already talked about. So nice thing about that is it's very friendly for homeowners because you don't need to do the pressure regulation at the valve as long as your water pressure is not above 70 PSI, like we talked about. You cap or eliminate the rest of the sprinklers. And then remember, this is the filter here. So if you have a small irrigation area, so basically coming off of here, this is a 1/2-inch connection. So you refer back to the slides. Remember, I provided how many linear feet you can do off of a single 1/2-inch connection. If that linear feet or that square footage is smaller than the area you're irrigating, you can just only connect from one area of your irrigation system and cap off the rest of the sprinklers to this. If, however, it's greater, you can generally leave 2 sprinklers on the irrigation system, and it's best to have those sprinklers spaced kind of across from each other in terms of where the layout is, and then convert both of them. And normally that will be just fine. And then one can cover 1/2 of the area, one can cover another 1/2 of the area. And that's coming from a 3/4-inch valve. If you're a large property and you have more valves, you might need to do more than 2. However, at a certain point, it becomes worth it just to put that pressure regulator and filter at the valve. Because remember, each one of these also is going to need to have that filter flushed out twice a year, at least once a year. And so you need to remember where this is and need to access it. The nice thing about having it at the valve is that it's right there. It's really easy. You can just flush all of them at the same time if you have multiple zones. But remember where you install them. That's crucial. I recommend putting some sort of rock, some sort of ornament in the garden, something where you will never forget where this is, even once the plants have grown in, once the mulch is laid down and all of that. I have definitely given advice to people who have used these to put in or to convert to drip. Everything's going well. And then 5 years down the road, all of a sudden, the water's not coming out. And I asked them if they've ever flushed their system, and they never have. And they can't remember where this thing is now buried in the landscape in the mulch. They're going to have to go find it, flush it out, and do that. So remember where this is. And if you're just putting one in, keep it accessible. So question from Lynn, define a standard irrigation area. Yeah, good question. So generally that means the area that would be served by one small valve. So just to go back, so what you can consider it is, if it's less than 375 square feet, no problem. You can just use one. If you are looping the system, it can be a little bit bigger, but you're still going to be no more than like 450 square feet. And so you can basically think each one of these can cover, if it's going in one direction and not looped, 375 square feet. And you're probably good for up to like 450 square feet for each one of these off of here. But if you are using more than one on a single zone, don't do it with two sprinklers right next to each other. You want to make sure that at least one of them is being fed kind of different. It's more, it would take too long to explain it right now. But long story short, if you're going to use more than one of these on a single irrigation zone, put them kind of across from each other, spaced out in the landscape. We'll give you the best results. And so here's an example of an area in our demonstration garden that used to be on overhead spray irrigation, that when we were replanting, we converted to drip, because originally, as set up by the contractors, it kind of just sprayed in one direction, and it was spraying over this dry stream bed, and it wasn't as efficient as we should have in our demonstration garden. And so here's what we did. This, when you see the picture from our demonstration garden, how it's purple pipe, that's because we're on recycled water. You will not be at home. So your pipe is, your drip line is going to be brown, and this is just a recycled water indicator. And so here's what we had. We pulled it out here. These were 12-inch pop-up sprinklers, so your piece will not be that long, but just kind of unscrewed that. And then here is our adapter kit. But because we had the Rainbird brand sprinkler in here, we were just able to take the guts out, screw that onto the body, and then we could connect and start irrigating from there. If you have, or if you are installing the pressure regulator and filter at your valve, you can still use all of the underground pipe from your spray system, but instead of keeping the sprinkler body, generally what you will do is you'll do something like this, where you're going to dig and you're going to access where the PVC pipe connects to the sprinkler body, and use the adapter that goes from the thread that you put thread seal tape on and screw in where your sprinkler screwed in. And then on the other side of that adapter, there's the barb that your drip tube slips over and secures on. And then for capping, it's similar to where you take out the guts of the sprinkler, and then you make sure you have the little rubber gasket that's in the bag with the cap, insert that into the cap, or lay that in the cap, and then screw down, and you'll get your watertight seal. And so here's just one example of, this is an example layout of if I had decided to convert my 1,200 square foot front yard to drip using this adapter, I would have had to use 2 of these retrofit kits. And remember that I said, in general, if you're looping it, the retrofit kit should be good for at least 450 square feet. But here I did all the specific math, and so I knew that I was actually going to be good for 2. So my general recommendations are a little bit more conservative. And if you want to really learn about real details for this retrofit process, including how you might assess your landscape design and your current sprinkler design for a given area, and then decide on the retrofit, whether to go with a higher efficiency spray retrofit, whether to go with these retrofit kits, or whether to install a larger single header and install the pressure regulator and filter back at the valve. We have a whole workshop just focused on that. And that workshop is called Retrofitting Spray Irrigation Systems for Waterwise and California Native Gardens, available on our YouTube channel. And so that's all about the retrofit process and what you might do. Some of the information overlaps with today, but there's a lot of different stuff. And then we also have on our YouTube channel some supplemental videos. And so there is one called Install Drip Irrigation Like a Pro, where you follow me step by step as I do this conversion for a single landscape zone. And then there's another one that's step by step adding a pressure regulating filter at the valve. And so those are available on our YouTube channel. And so I'm going to go through this next part, which kind of goes through it as much as we can in the workshop, kind of showing the part by part, but I'm going to go through it pretty briefly for the reason that really that's something that's best to absorb by watching a video where you can see me do it step by step. And so if you're going to want that, then that's really a better resource than I can show kind of step by step with just static pictures. However, it is an important part of the workshop, so I am definitely going to cover it. So you're going to start with your irrigation valve. And if you need to add your pressure regulator and filter, you will do that. And so basically you can see if you're digging up the whole area and putting in new, that's kind of what it looks like. The feed side comes up, goes through the valve, pressure regulating filter, then goes back down. If you're installing a new entire manifold off of your main line, always make sure you put in a shut-off valve. So if you need to do work on this, you can close that down without needing to turn all of your water off. And so we already talked about the pressure regulator and filter, so I won't go over that again. Just some examples, just what the one filter looks like inside. And then if you don't have the automatic valves, you can install all of this just off of a hose bib with an adapter that you can get at the irrigation supply store. Hoses have different threads on them. There's what's called hose thread and what's called pipe thread. If you look at them quickly, they look similar, but for whatever reason, I don't know, and it's a pain, but historically, hoses have a wider thread. And so if you're going to go from hose parts to actual irrigation, like landscape irrigation parts, you need an adapter that you can get at the store. You just need to know to ask for it. And then you can get, it's a mini backflow preventer. And then you can have your filter and pressure reducer, and then the adapter that will get onto your drip line. So you can do that. And I've done that plenty of times on landscapes where we just weren't going to have access to automatic valves. And then if you want to, you can also get a battery operated hose end timer to automate when it comes on and how long as well. And so for that larger drip irrigation zone, basically I'll just walk you through. That just reviews stuff we've talked about already. But this is after planting what we were irrigating, this young, what will grow into be a taller hedge of different California native plants that will be a loose hedge, great for habitat. This is what we were building. And so we tapped into the pipe connected to the valve here because there used to be an irrigation system, just not a great one. So we tapped into the 3/4 inch pipe and converted it to that 3/4 inch blue lock using a similar piece that threads in and then has the gasket style seal where you just push the blue lock in. And for a standard installation, you can just do all that with PVC. But either way, we got the 3/4 inch pipe down to one end of the landscape. The blue lock stuff cuts with just a standard PVC cutter, and then install an elbow. And then figuring out where we're going to put our first line. And so here we decided to do it 6 inches off of this curb. Oh, actually, we did it 9 inches off of this curb. And what I like to do is these are the little staples that are used to hold down the drip irrigation. Sometimes they're called jute staples. You can see one here. You buy them in a big bag. They're cheaper and you can get them in much larger bags if you go to the landscape supply store rather than Home Depot, and the quality is usually a little bit better. And so just cutting the line and installing the T at each one. And you can see if you're doing something where there's a bunch of adapters, whether it's PVC or this blue lock stuff, and you need to screw in the adapters that go to drip, you can do them all sitting in the shade ahead of time. You don't need to be kneeling down in the dirt when you do that work. And then it's just one part that you need to put together. And here with this, we just push them together, tack that down with the staple, run some more line, do the next one, and here you go. The blue lock stuff is available online through a special order, and Drip Depot is the main place where I've been able to consistently get it online. You can check other places as well. I never like to recommend just one spot, but that tends to be the easiest place that I've found online that consistently has it, if you're interested. And we talk about it a lot more in some of our other irrigation classes as well. So if you want to learn more about it, you can check out some of those. And then from that header being installed, then when you install the actual tubing, so that's this stuff. Oh, and here we go. Here's the picture of the staple. And so the tubing, which again here is only purple because that's what we need to do for our recycled water, cuts. You can use a normal PVC cutter or even a very sharp garden shears. Very sharp garden shears is a decent way to go. If you're installing a lot, it is worth getting sometimes it's called the polypipe cutter at the hardware store, in the plumbing aisle, or from the irrigation supply store. And it's basically just a very sharp blade that you clamp down, cuts the stuff very efficiently. And so cut as needed. And when you're pushing these onto the adapter, one of the reasons why sometimes you need to cut is because you need to make sure that you're pushing it onto this adapter at a place where there's empty pipe and not right on an emitter, because that emitter takes up some space on the inside and you can't push it in if there's an emitter right there. So you push it in, just kind of twist it on. And it's very easy on a hot day. One trick is that if you're going to be using this stuff, leave it out. I mean, generally you don't want to leave it out in the sun if you're not using it yet, but just leave it out in the sun for a few hours right before you start, if you're not starting right early in the morning, and it will warm the line up. If it's a little bit warmer, it's a little bit easier to work in. Another thing that I've heard of people doing, if they have an outdoor outlet, depending on where it is in their backyard, is using a hairdryer on it. And then the final thing that I've heard some people do, I've never done this myself, is filling hot water into some sort of thermos and dipping the end into the thermos right before you push it in. But I also know someone who tried it and they just ended up spilling very hot water all over themselves. So if you do that, be careful. And then you can see here it curves. So at some point it got larger in this area. So we teed off with a fitting and then a elbow fitting and then added another line in. And you can see when it runs, same thing. It doesn't always connect all the way at the top, but once you go down a few inches, it will connect. And then down at the far side, so that everything reconnects nice and evenly, it is a best practice to then do what's called an exhaust header, where you use that larger pipe again and the fittings and adapters again, so that when the water gets to the end, it could kind of evenly move around, and that the water speed where this is all potentially coming together and then going back through the individual lines through the larger pipe is lower. It's not the end of the world if you don't do that in most kind of residential size systems, but it really is the best practice. And then you can see here just an example of one thing that's nice about the drip irrigation. Like, there'd be no good way with a spray irrigation system to deal with this weird little corner without having lots of overspray and things uneven. But here for a small area, you can just tap off the closest line and then kind of create some loops. And then the flush down at the end. So on a 3/4 inch line, you would get a threaded 3/4 inch, what's called a ball valve. And then the first time you turn on a drip system, you always want to be careful not to get dirt in the lines, but inevitably you're working on the ground, some happens. So it's very important the first time you turn on a drip system, have this flush valve down at the end in the open position, which is going to be in line with the direction of the pipe, not across it. In line is going to be open. And then when you turn it on, just let the water run through for a minute or two. And so any little dirt or debris in there is going to get pushed out. It's easy to do with two people, one person down at the valve and one person holding it. But also if I'm doing it by myself, I would just put a rock underneath or something, just so that this isn't sitting down in the dirt. And there we go. Repeated that. And then again, for the smaller, if you're all using all the 1/2 inch, then you can do just the manual flush valve that has a barb and it just inserts into the 1/2 inch line. In a more professional system, that goes down into a valve box, but in residential systems at home and even at our demonstration garden, normally I just let this sit in the mulch with everything else, and we do something to mark it or put it in a very obvious place where we can find it later on. And so sometimes they have a gray back, sometimes they have a green back. but they're all basically the same thing. Just depends on the manufacturer. And then one quick note, drip irrigation does work great in raised bed vegetable gardens. All of these principles, the filtration, all of that is pretty similar. The only thing is that I like a much closer spacing for vegetables because we have small plants. Sometimes we have seedlings that are growing in. Personally, when I plant seeds to get the seeds up, I always water by hand. But then as soon as they get going, I just convert to running the drip. Standard landscape drip irrigation, the closest you can buy that is 1 foot apart between the emitters, which for me, I believe is too far in between vegetables, especially if you're growing all sorts of different vegetables at different times of the year. So I highly, highly recommend that you make sure that you use drip with a 6-inch spacing. And that could be obtained by there. Usually you can find that in if you go with that 1/4 inch drip line. So this is also the stuff that I recommended for containers. And this actually locally, the place to get this is at Home Depot. They're the only place I know that sells the 6-inch spacing. And if you are using this with the 1/4 drip line, just know that the pressure for this needs to be even lower. It's down at 25 PSI, but where you buy this, they will sell the same brand, the pressure reducer that will be compatible with this. Other than that, I don't have time to really do much specific related to it, other than to tell you that we have a whole workshop that we teach, and the recording is online, for efficient watering for fruit trees and vegetable gardens. So that's at cbwcd.org/YouTube, where we go way into that. And then maintenance is simple. There's just some things that you need to remember. We talked about, but I will keep saying it, maybe this is the last time, that you need to flush your filter. So it's very easy to open it up. You pull this thing out, you put it underneath a faucet, or especially if there's stuff in there like a high pressure nozzle on a hose, but just rinse out this filter. You replace it back in, you screw it back together. You're good for another at least 6 months. And then the other thing to do is every once in a while, it's good to manually turn your system on when you're around, especially if it goes off at night, and listen for any leaks. And so take a look at this.
Hi, this is Brandon Burgess with the Chino Basin Water Conservation District, and today I'm going to be sharing some water-wise tips for fix a leak. Today's water-wise tip is how to look and listen for a drip irrigation break. So let's go ahead and turn on our system and see what we find. Okay, now that we've turned on our system, we walked around and we hear in this area, something that sounds a little different. This is where we know to start looking for the leak. Because drip tubing is typically covered in mulch, you can't visually see. So as we peel back, found a leak. This is a tiny tear in the tubing, which could easily be done with your shovel when you're out there gardening. But since it's hidden underneath the mulch, we wouldn't have known unless we looked.
Okay, so that's something that is very much easier to show in person. It will not always be that loud in the real world, but we had a microphone nearby for the purpose of that video. But basically, turn it on every once in a while and walk through your whole landscape area, and you will hear it if that is happening. And then if that's the case, it's really easy. You can just cut the line there, and with one of those fittings that has the barb on both sides, you just push it back together. And so to manually run that, it's best to manually run it from your timer. And if you don't know how to do that, you can refer to your timer's manual. If you don't have it, you can pretty much always go to the manufacturer's website and look for the manual with your model number and download a PDF of it. Or like we talked about with valves earlier, you can manually turn on your irrigation at the valve. Although between the two, the timer is the better way to do it, because then you're not messing with anything at the valve. And then so always keep those extra parts. So if you do have a little tear, this is the part you need. You just cleanly cut it and push that pipe back together on each side. And look for breaks. So this is a classic example of why I don't generally recommend the spaghetti tube and the little emitters. That stuff just falls apart. Here is a case where they also didn't have adequate pressure reduction, but it's very common. People trip over this, they just don't know. Here is a case where that compression fitting which I mentioned that I don't like as much as the barb fitting because over time it breaks. This is exactly what happens when the compression fitting comes apart and then water's just shooting out. And anything that was going to be getting drip irrigation from this side is not getting anything. So pretty important. And even with this, like we've had this happen in our garden because the original contractor did use some of these for the installation. And sometimes it takes a surprising amount of time to find this. And so what I am going to do is I see that there is a few questions. Oh, we've already got to some of those. Okay, so I'm going to answer just one question related to the timers, and then the other ones I will get to at the end because I really want to make sure that we have time to go through the irrigation scheduling. There's a lot to cover there, and it's going to be a little tight, but it's important. So the one question is using a timer or valve setup on a hose bib. Yes, I've definitely done that before. Can it be used for containers seasonally? Absolutely. Would you need a check valve in addition to the screw-on backflow valve? The screw-on backflow takes the place of the check valve. So that should be just fine. Good questions, Jeff. And then everything else I will get to at the end. A real quick one I will answer from Francesca. Drip irrigation go above or below landscape fabric. If you're using landscape fabric, it goes down below that because that's going to be best for the distribution of how the water falls directly on the soil. Okay, so for irrigation scheduling, this is super important because if we are installing our high efficiency drip irrigation systems, but we're running them for way too long, that's still not efficient irrigation. And so a couple of key concepts. Also know that I'm going to be going through this relatively quickly, but for those of you who are really going to try to apply this, I have an hour-long kind of just specifically focused on this topic video on our YouTube channel that's all about irrigation scheduling for water-wise gardens that you can look at. That's going to have all this information and more explained in much more detail. There's just only so much we can cover in a single workshop. So irrigation scheduling, important concept to know is that when we talk about providing for the water needs of plants, we talk about it in inches of water. Just like rain, where you might hear it rained an inch last night. That basically means the whole area was covered in what would be, if it all accumulated at once and was right above the soil surface, an inch deep of water. The reason why we do the recommendations that way is because gallons is always going to be very specific based on the layout in your garden. And so that gets really difficult to provide any recommendations. But we can say, if you have this type of plant in this area, then pretty reliably it will need maybe every 2 weeks, 1 inch of water. And then it's all just about, okay, how long do you run your irrigation system to provide that? And we will go through all of that. But that's why we use inches. And then also note that when you look at watering recommendations, they're always for established plantings unless noted otherwise, which means when your plants go into the ground, kind of fresh go into the ground, they're going to need more water until they get rooted out, until they grow some. In general, water-wise in California native plants, if they're planted, especially in the fall or the winter, are going to want water in most areas about once a week the first year, or maybe 2, and then can be tapered off to a deep watering every 3 to 4 weeks in most cases. And that irrigation once a week in general is going to be somewhere between 0.5 inch to 1 inch of water the first year. If in doubt, you can go with 1 inch of water per week through the first year to the landscape area for a new landscape. That's generally what I do when I need to kind of get a landscape going and kind of walk away. But sometimes you can get away with a little less water than that. It's going to be about digging around in the soil, knowing that you are keeping the plants moist through their small root zone as they grow in, and not watering, generally not watering more than once per week though, because things do need to dry out a little bit. You can't keep them completely moist with the water-wise plants because that's not good for their health either, even as they're getting established. And then you begin to taper down. Usually by year 3, healthy plantings can be fully onto whatever their established schedule is going to be. And then the other for figuring out for your area how much water you're going to need to provide is you're going to need to understand this concept called reference evapotranspiration, which sounds very complicated. But basically what that means is reference evapotranspiration is a way of providing a number in inches of water of what the highest water using plants would want in a given area and at a given time of year. So basically that's turf grass, or in agriculture, alfalfa, or also sometimes like vegetables are very close. No, in any given area, those are the things that are going to need the absolute most water. And so it's useful to quantify that, because then you can say, well, for this plant type, it's this percentage less. For that plant type, it's that percentage less. And I have made some charts for our local area to kind of do some of that math for you. But this is the general way of understanding irrigation demand. And so, not surprisingly, in the hotter areas, it requires more. So what does that mean? So that means, on average, if you look at these months throughout the year, for example, July is pretty much always the hottest in California. Palm Springs, turf, or that reference evapotranspiration amount, over the month of July, almost 10 inches of water are required to really keep turf completely happy. Riverside, still really hot, but that's a little over 6 inches of water. And actually, the last few years, it's been a little bit higher. Some of my charts are more updated than this graphic. And then San Francisco, not surprisingly, quite a bit lower. And so by knowing this, you will see what we can do with that in just a moment. And then just for kind of general reference, you can see the Inland Valley area is grouped pretty closely. And this is for the whole year if you add it up. Santa Monica, quite a bit less. Lancaster out in the desert, quite a bit more. And so by knowing that 100% amount quantified in inches, you can then know that that's for high water use plants. If you have what are considered medium water use plants, that's going to be between 40 and 60% of that total amount. Low water use plants generally down around 30% or possibly even lower. If you live in inland Southern California or Southern California in general, or a climate that's similar to that, for most of the water-wise plants we would grow in our landscapes, we have a resource that makes it even simpler than needing to know that curves. On our Inland Valley Garden Planner website, we have detailed information for the top 350 water-wise and semi-water-wise landscape plants you're likely to use in Southern California. And each one of them has an irrigation schedule, which basically says, run your system how many times a month, how many inches to apply per run, and a total of how many inches per month. And using that, you can group plants with compatible schedules, and you can find all that information online. So you can kind of skip all of that. If you're in more coastal Southern or Central California, you can just water, a bit less, 10 to 25% less than this in the warmer months, and that'll probably get you pretty close. So that's kind of a shortcut. And 1 inch just happens to be a very common way of doing things, where it just so happens that what works really well in Southern California in the hotter months is for moderate water plants, providing 1 inch 3 to 4 times a month. For Mediterranean kind of general low water use plants, providing 1 inch every other week, twice a month. And for true California native, very low water plants, providing 1 inch about once a month to once every 3 weeks. And so we have all of those schedules. But if we are really going to kind of figure it out and then also determine what that means, we're going to put it all into a run time. And so what does that mean? Well, if you know, okay, then I need to apply 1 inch of water. How do I do that? Just a note, if you have a sprinkler system, on the Inland Valley Garden Planner website, right underneath these, there's some links, and one of them gets you to a couple of calculators. One, if you have an overhead spray system, And then another one if you have like a drip system that is not our standard kind of irrigation grid. However, hopefully I've convinced you by now that if you're putting in a new drip system, that irrigation grid is going to be the best way to go. And if you put in that grid and if you do the proper pressure regulation, you can use a chart like this that will tell you what's called the precipitation rate of your irrigation system. So for example, if we use this chart for our standard, what we use in our loamy or sandy soils, if we're using our 0.9 gallons per hour emitters and our emitter spacing is 12 inches, that gets us here. And then with this chart, and we had things be every 18 inch in terms of the distance between the lines, that means that our system precipitation rate is 0.96 inches per hour it's running. That's what this chart shows. And if yours is set up different, you can use this chart to get that. So 0.96, we can pretty much round that to 1 inch per hour. And so if we know we need to provide 1 inch of water, we can know that we need to, if I need to water an inch, water for 1 hour. If I'm going to be providing 1 inch per week, you need to water for 1 hour, 1 time per week, 1 inch per month, 1 hour, 1 time per month. If you're programming it into your irrigation timer and you have a water-wise garden, those days of the week schedules don't work, but almost all modern irrigation timers also have something called interval, where you can tell it how many days in between. So you can say water once every 14 days for this many minutes. So for 1 hour, 60 minutes. So if you have a more specific situation, if you're not going to be using the Inland Valley Garden Planner, what you want to do is for your local area, you need to find a chart of the reference evapotranspiration, also sometimes called ETO, for your area. And that is available definitely for everywhere in California. Sometimes the easiest way to find it is just to look online. If you're having trouble with that, you can also check in with your local like master gardeners, or if you're in another state, your local extension system. That information is going to be available somewhere. And normally you can get that on by the month. And so here, for example, this chart, if you are in inland Southern California, this is going to apply Riverside, most of Inland Empire, San Gabriel, San Fernando Valley, all pretty similar. Here, basically, which means if you are growing those highest water using plants or that reference evapotranspiration in July, it's always going to be the highest, you're going to anticipate needing to use about 7.1 inches of water across the entire month. But if you have low water plants, that's going to be about 30% of that much. That means you're just down at 2.1 inches across the entire month. And then you're going to decide how often to water. Medium water use, shrubs and things like that, once a week generally. Low water Mediterranean plants, like I mentioned, every other week. And California native stuff about once a month. With the true California natives generally, though, it's a little bit different. And for the most part, after establishment, in the months where you get less than an inch of water, you're just going to water 1 inch. Seems too simple, but the reason why that works is because in the summer, they kind of want to go dormant. And so even though it's hot, they don't need much water just to keep them a little bit hydrated, looking a little bit good, but they're adapted to not have much water at that time of year. And then in the spring and the fall, they want a little bit more water. And so, but it's cooler. And so that 1 inch works there. So generally, with most established California native plants, 1 inch of water up to maybe 1.5 inches in the months it doesn't rain, or if it only rains a little bit to supplement. But so for example, let's say we use this for a Mediterranean climate landscape, lavenders, rosemaries, things like that. In July, in this area, I know I need just over 2 inches of water total, and I'm going to water twice in that month. It's a general recommendation for the established plants. So each time I water, I'm going to provide 1 inch of water. For fruit trees, each time I water, I'd be providing, if I was watering once a week, 5.0 divided by 4, and that. And then to get your minutes of runtime, you multiply by 60. So every year, month, and week is different, but that gets us in the ballpark. This is just a more kind of mathematical way of explaining what I just did by the example. And just to kind of go over it that one last time, really kind of making it clear. If I'm going to be watering twice per month in July in the Inland Empire with our grid, that's the 0.9 gallons per hour emitter, every 12 inches along the line and 18 inches apart, my irrigation system is going to be providing just about 1 inch of water per hour, 0.96 to be exact. So on average, I'm going to water twice. So it's 1.1 inches of water each time, round up a little bit. 1.1 divided by 0.96 inches per hour. So if it was something weird from a different spacing, 0.45 or something, that's what you do. Your amount of time that you want to, or amount of irrigation that you want to apply each time divided by the inches per hour, your precipitation rate, tells you how many hours to water each time you water. Multiply that by 60, that gives you the minutes per run, and then you have your interval. And as I mentioned, for California native plants, it's a bit different. It's about 1 to 1 inch, 1.5 inches per month. And then the last thing on this, and again, there's the much more in-depth version of that timing talk available on our YouTube channel, is that if you have a smart timer or a weather-based irrigation timer or irrigation controller, and here are 3 of the common ones. There's the Hunter, HC or Hunter HydroWise, Orbit makes one, and Ratio makes one. To me, Ratio for water-wise plants, there's not really quite enough options in that to set that up how I really like from what I've seen. They might have some new features, but both of these are pretty common. Basically, what you can do is you can figure out your July maximum amount of water. And then instead of needing to change it up for each month or each season of the year to provide less water when it's cooler, you can set it up to automatically connect to local weather stations, and it will automatically know to water less at those times of year based on the weather over the last few days or over the last week. If you do not have a smart irrigation timer or weather-based irrigation timer, there's a couple of things you can do. But the vast majority of irrigation timers have what's called a monthly adjustment feature. And what that means is that as long as you know the numbers for each, the evapotranspiration numbers for each month of the year on average, you can then calculate what percentage of the maximum are each of those other months. So for this local area, inland Southern California, I already did that math for you in this column. And so for the monthly adjustment, that basically means that into your irrigation controller, you can put the minutes for July if you're going to be, for example, running it once a week. And then instead of needing to change that minutes all throughout the year, you can have it automatically enter when you go to the monthly adjustment. You would, for July, it's 100%. For June, you put in 96%. For May, you put in 88%, et cetera. For January, 32%. And it will know to adjust the minutes of runtime automatically as long as the calendar is set correctly for each of those other months. Now, because we get weird heat waves at all different times of the year, it's going to be much more accurate for having that weather-based irrigation controller. But this definitely will help save water and help you being more likely to water appropriately than if you're just leaving the same schedule year round, which is going to have you overwatering in a whole lot of the cooler season of the year. And so I apologize that this had to be kind of pretty brief, but we had to get you through how to put together the irrigation systems. And again, if you're actually going to be doing this, I encourage you to check out that longer recording on the YouTube channel. And then just a last note, any landscape, even with low water plants and a drip irrigation system, can be very high water if the system runs too often and too long.
And especially with drip, because you're less likely to have runoff if the system is installed well, really making sure that you're watering for the appropriate amount of time can really help. If all of this math was just way too much for you, you can take a very old school approach, and there's nothing necessarily bad about the old school approach, where you figure out how long you need to water by running your system for a while, digging in the ground and seeing how deep the water has penetrated. And for most landscape plants, for water-wise stuff, you're going to want that water to have penetrated more than a foot by the time you're done watering. So figure out how long that takes. And then you're going to want the water to be pretty dry, or you're going to want the soil to be pretty dry after the plants are established in between. Not bone dry, but at least 4 inches down, you should be able to dig, and things should have dried out pretty significantly. Maybe there's a little bit of ambient moisture left deeper. And so if you need to do your adjustments by that, you can do that as well. In general, you will water more accurately and be able to save water if you rely on that other kind of approach, the little bit more technical approach. And then also use your observations still. Even if you're doing the technical approach, don't just completely forget about it. Keep an eye on your plants, check your soil every once in a while, make sure things are looking good. And then some other important tips to save some water. Remember to turn off your controllers when they're not needed, like after rain. With those smart timers that are connected into the weather stations, they can often know that, and you can set them to turn off for a while. Periodically check systems for leaks and other issues, ideally once a month or so, but at least every 3 months. And don't be afraid of your irrigation controller. Read the manual. A lot of the manufacturers have YouTube videos explaining the controllers. They're easier than you think. And a lot of the new smart ones can connect to your home Wi-Fi system, and you have a much more intuitive interface that you can log into on your computer. And so in the end, all of this matters because it promotes plant health. Many plant problems, whether it's disease or dying, are due to overwatering or underwatering. So that's super important. It protects water resources, which has many far-reaching environmental benefits, from habitat to making sure that our groundwater basins don't lose capacity because of soil subsidence. It keeps your water bill down, but it also, if we're all managing water well, keeps our collective costs in terms of infrastructure investment needed by our water agencies down, which eventually we would need to pay for in our water rates. And it also means your plants are more likely to live and thrive, so you won't need to replace as many. And it helps keep your yard looking great. And remember, there's always some room for adjustment sometimes. So check soil moisture periodically, adjust your irrigation run times as necessary, even if you're using the chart. In most home cases, you'd be digging around with a shovel every once in a while, not right at the base of the plants, but out where you won't be doing much damage. Or if you're really into it, you can purchase something like this, which is a soil probe, which, as long as your soil is not too gravelly, you push it down into the soil and extracts a little sample that you can look at, and you can see how much is wet and how much is dry. And so with that, here are some of our links and resources. I am going to start answering all of the questions. Thank you for sticking with us. And for those of you who need to leave right now, I am going to very quickly launch a closing evaluation poll. And please, please quickly, there's just 4 questions. Let me know what you thought of this workshop. It's anonymous. So I would love your honest answer. This stuff is pretty complicated, and we are really trying hard, not just to provide some general kind of, yes, you should put your drip irrigation systems in because they're good for water consumption, but we're really trying to teach people in the best way we can how to have a chance at doing this stuff with knowing that you're not going to be irrigation professionals. So we look at all of the feedback. We always take it into account. And then also, if you have any other feedback, please let us know in the chat. If there's anything in this class that was particularly useful to you and you are going to be using in your landscape for sure, anything that wasn't clear to you in the past and you think that this kind of cleared it up, let us know. Or if there's anything that wasn't clear and was super confusing and you think could be taught better, also definitely I would love to hear that, because every time we teach this, we're always tweaking it and trying to make it a little bit better. And so with that, I'm going to start getting through all the questions. So on the topic of containers, from Dr. Igor, has a suggestion for use in containers. He has been successful using drip emitters, 1 or 2 gallons per hour, connected to the 1/4-inch porous tubing, which is also the soaker tube. Okay, so if that's working for you, then yeah, that could be a good way to go. With pots, it's really just about getting water evenly to the root zone and keeping an eye on it. Okay, let's see. And I'm going to start checking if people are still here. Okay, that's not here. From Karen, how would I set up transitions and lines for different water zones that need different schedules? Good question. So I'm sorry if that was not clear earlier. That happens on different lines. So areas that need different, so a zone is an area that's watered by one single valve. And so for the areas that need different schedules, they're going to be connected to different valves. And then each different valve can be assigned to a different, what's called an irrigation schedule within your controller. And so you can have a schedule in your controller for your low water plants, a schedule for your fruit trees, and a schedule for your vegetable gardens. And all of those would run off of different valves that the controller turns on the different schedules. Okay, so for Dr. Igor, let me make sure you're still here. So suggestions for estimating scheduling or duration of water and frequency using on drip on containers and raised beds. For raised beds, if you check out our online workshop, that's efficient irrigation for fruit trees and vegetable gardens. And also we have a raised bed workshop that gets a little bit into it, but really the efficient irrigation for the fruit trees and vegetable gardens, we go way into that. For containers though, it's really specific. I don't give general recommendations because it really is based on everything from your plant type, your soil you're using, your container type of material, because like terracotta breathes more and dries out faster, plastic holds water in a little bit more. And because there's so little soil capacity, like how much sun the container's in makes so much of a difference. So it's really just about making sure that your system waters the whole root zone of the container evenly, and then keeping an eye on the container. And in most container plantings, once the top couple of inches are quite dry, then it's going to be time to water again. And it's going to be more volatile based on the time of year and the weather than the typical landscape planting is going to be for the schedule, just because there's so little soil root zone in container plants. Okay, so from Lynette, it seems like I have to be a math expert to calculate everything. Do I really have to figure out everything like that? If that is intimidating to you and you're just not going to do it, that's fine. Just know then that it's more on you. If you're not going to start with that general advice, then it's more on you to be digging around and making observations in the garden. You can't just set up the drip irrigation system and say, I'm going to water for an hour, twice a week, without any reference to what your plant type is or where you live or what the weather is. So if you are in Southern California, you can start with those general recommendations for the plants on the Inland Valley Garden Planner. And if you're more on the coast rather than inland, cut that a little bit down in the warm season. But ultimately, if you want to start with for California, generally, general water-wise plants twice a month after established, California native plants 3 weeks to once a month after established. Generally, just making sure that you water deeply through the root zone by poking around, and then check to make sure that things have dried out some before watering again. Like that's a decent place to start for the plant health. And then go from there, refining with your observations. So from Karen, can you give us a round number on the total cost for setting up the system from scratch? It depends so much on the number of different valves you want. If you are actually installing the valves yourself, sometimes people have a contractor install the valves and then they'll do the rest of it. If you're having a contractor install it, different parts. What you need to do is generally make a parts list and then go from there. I have done some basic calculations in the past, and I don't have that flyer with me right now. I am sorry, but really the best thing to do is, since you're going to need to buy the parts anyways, is doing a rough estimate and then going to the irrigation store and kind of having them help you put together the costs. And so, yeah, that's just part of the process. However, I will say, if you are doing a garden project from scratch, it is not uncommon to spend just as much, if not more, on the irrigation system if you're starting from scratch than you do on the actual plant material if you are planting plants small, which you should be doing. And it'll help give you extra budget for your irrigation system. And then another question: would we need to buy separate valves or controllers for each water zone? Correct. Yes, a zone means literally the area of the landscape that is operated by one valve. What if you don't? And then the question is, what if you don't have enough supply sources? So all of the valves are connected to a single supply. So basically, a main line that at some point comes from your water meter or from your house, just any part of the water service to your house that's always pressurized, and ideally is a 3/4 inch line. So like if your house reduces to 1/2 inch, it needs to be a 3/4 inch line. So sometimes you might almost have to go all the way back to the meter. But if there's an existing hose bib in your backyard, any always pressurized 3/4 inch line will then connect to what's called the valve manifold. And then the valves, the way the irrigation controllers work is that they only run one valve at a time. And so as long as all those valves are connected to a single water source that's reliable, then you can have as many valves as you need. And then your irrigation controller, you purchase an irrigation controller that is already set up to accommodate the number of valves you have. And so the smallest irrigation controller that you would actually plug in is usually for 8 different valves or 8 different zones. This is all that's needed in most houses, but you can go from 8, it goes to 12, then sometimes to 16, and then on if you need a larger capacity number of different valves. And so also, if you want, we don't cover too much really explaining like the valve manifold in this class, but we do have a irrigation basics class, and we have a recording of that on the YouTube channel. So you might want to start with that to get into more about valves. Generally, because when you put together valve manifolds, you're working on the always pressurized side of the line. And if something's not glued perfectly and something breaks, it's just going to keep running and running and running water. If you're not confident in your plumbing skills, that's best to have set up by a landscape contractor or a plumber who can also do valves. And so I don't teach that because there's just a little bit too much things that can go wrong for me to be comfortable encouraging homeowners who have never done this before to be installing valve manifolds from scratch and doing that cutting and gluing on the always pressurized side of things. However, I'm sure there's plenty of YouTube videos online if you do want to find information about that. Okay, and getting down to the last couple of questions from Rodolfo. Do you use mulch in containers? Where do you place the dripper? I do use mulch in containers, especially in the summer. And what I like to do is that 1/4 inch inline drip line, and I'll kind of do, depending on the actual size of the container, either a loop, or if it's a larger container, a small spiral, so that there's a number of those emitters distributed throughout the top of the surface of the container. And then after that's in, I turn it on, flush it out, test it. For those small spirals, you can get at the same stores that sell the 1/4 inch line. There's a tiny little valve that goes on the end that lets you flush it and close it. And then after that's done, and I use some of those staples to hold it down where I want it to be, then I will cover that with mulch. And then you don't really have to see any of that anymore. And the mulch is good to help conserve water in the pots, definitely. And last question from Cheryl. Are water drills a good idea for deep watering? That is a good question. And so water drills, or sometimes there's those PVC pipes with a spike on the end that have perforated holes, and you pound them into the ground. In general, with a good irrigation system that is set up to run appropriately and water deeply and occasionally, like our water-wise plants want, we should be able to get the water to penetrate as deep as we need it to without running off. Because if it's going to water, if we're going to need so many minutes that's going to start to run off, we use those multiple start times or cycle and soak that I talked about. That I will generally want everything to get a pretty deep soak. Now, the only exception to that would be, like, what if you had an area of landscape where it's just like one tree where you're going to want to water deeper because, you know, its roots go farther down, and everything else are like smaller perennial plants or, you know, small shrubs that are much less deep rooted, then maybe. However, those spikes still only will get that water deep in just a couple of areas. So what I would be more likely to do is, if I'm designing my irrigation system from scratch or doing a large retrofit, is I would provide a secondary zone for the tree that will allow me to run that drip irrigation system, or run a drip zone of my irrigation system longer just for that tree. So only that area within the tree's root zones gets that super deep irrigation. Or I might even use something like even though it's not as regulated and not as good as the drip system overall, sometimes a quick and easy way to give those trees an extra deep soak would be to use like a soaker hose that connects to a normal hose and run it for a long time. That's not to say that I think that, you know, those water drills, if it's that or nothing, they certainly can be helpful. But because generally those will only water in 1, 2, 3 different areas where you put them in, I prefer approaches, whether it's with drip or if needed, a soaker hose connected to a hose, if there's not capacity to put on a whole nother valve for just that tree, that do a slow, deep watering over a greater area so that those roots can find water in more than just a couple concentrated places. If you're using a soaker hose, generally laying that out kind of close to the drip line or the edge of the canopy of a tree is going to be where you're going to get the most bang for the buck in terms of a deep soak that the tree roots will absorb where they're looking for that water. So that was our last question. Thank you very much for joining us today and going through all of this information. Again, if you don't get our newsletter, please sign up for that. And then in about a week or so after just some light editing, this will go up on our YouTube channel. We do have a recording of a past version of this workshop that was taught by Brandon Burgess, who's our conservation specialist here, who is an absolute irrigation expert as well. So if you're just looking for something to quickly reference, you can check that immediately. And then by the end of the day today, at that cbwcd.org/presentations, I will have the PDF file of all of these slides posted. So thank you very much for joining us today, everyone, and have a good rest of your weekend.